And am I on my yellow?
Yeah.
Okay. Thank you, Willem. It's interesting how I became chief cook and bottle washer, that I mentioned to Willem, hey, I'm working on a solar project and it's going slowly, unfortunately. And he says, great, you're giving a solar talk. So we quickly changed this because, do you want to sit and listen to me talk for 2.5 hours? No, you don't. We're going to have John Maxwell is helping, Willem will be presenting, Tristan, Dave Mack, and Dave Mack is going to do an interesting thing where he's going to try to do some of his technical direction work up from here. So welcome to RMHAM University. Willem, thank you for all you're doing to put these on. Yes, next month we are going to have Jim Dixon, and we also have another RMHAM event kind of happening the same day. That's Winter Field Day. And we're going to participate as Rocky Mountain Ham Radio, as well as the Longmont Club and probably Region 1, District 1 Aries up at my house. And if you're up in the north end of town and you want an informal educational field day, give me a call and you're welcome to come by and freeze your doodads off in the snow. So we're going to start with solar. And how do I get the presenter to go next slide? Oh, we have a clicker.
Push this button.
So when John and I do things like Central States VHF conferences and all, we always hand the presenter one of these and they go, how do I work this? And he says, push the big button. So happy solstice, everyone. This is December 21st, 2 days before Festivus. So this is the second most famous holiday of the season here. The winter solstice, the shortest period of daylight, longest night of the year, and when the sun is at its lowest daily maximum elevation in the sky. And Willem was telling me he was having some cheating problems at the university. I said, okay, I better put a source. This is from Wikipedia. So I did not violate the honor code, Willem. So why are we talking about solar on the shortest day of the year? Good timing, Willem. So we're going to do some theory, and we're going to kind of work this where the various instructors, and Willem, you need I think you did this. Oh, you've got a mic. So we're just going to kind of chime in and chime out. I don't even know. I did the editing and tried to make all the slides big enough to see, but I don't even know who did all of these slides. This was really a great group collaboration. I encourage you to ask questions, interrupt us. We'll be doing the same. And is this one of yours?
Yes.
So
solar power has been around about as long as electricity has. So it was first discovered in 1939 by Becquerel.
1839.
What did I say?
1939.
Oh, well, that's a long time ago, too. And strictly speaking, there's two different terms that we use, photovoltaics and photoelectrics. Photovoltaics is kind of what we are interested in here today, right, where the voltage actually is developed within the material. Photoelectric effect really has to do with when the electrons are emitted into a vacuum or something like that. But so the photovoltaic effect has been known for quite a long time. Around the 1900 is when Einstein really put the theoretical basis of it, and we got to understand it more. But really, where photocells were developed was for the space race. So back in the 1950s, Bell Labs in particular started to develop solar cells for applications where you couldn't run a power cord up to it, in particularly spacecraft. And so the first spacecraft that actually was solar powered was Vanguard 1, 1958. It had 6 panels on it that generated 100 milliwatts. And only 4 years later, Telstar 1 got put up, which was the first commercial spacecraft for television, and it was also solar powered. In those days, the solar powers were just little panels that sat on the outside of the spacecraft, not the big wings that you see on most modern satellites. But basically, that's where it all came from. The use of solar power for electric use on terrestrial applications really started in the 70s with the energy crisis. A lot of it was used for just direct thermal generation because, you know, we're heating water with electricity or gas a lot, and that solar power works for that as well. But the use of solar cells to generate electric current that we could use to power sites is actually a relatively recent development, maybe the last 50 years or so. So of course, this is RMHAM University, so I'm gonna make you suffer through my first love, which is nuclear physics. So obviously, in the sun, energy is generated by nuclear fusion. The fusion doesn't actually directly generate the photons that we use for solar power. Instead, what it just does is it generates a lot of positrons. Those are annihilated by electrons, and the result is a lot of heat generation. And then most of the solar flux that we see is actually because the corona of the sun is heated to somewhere around 5,700 degrees Kelvin. And so that you have a thermionic effect where you basically dissipate that heat as a bunch of photons, right? So that's where it all comes from. That energy decreases as 1 over r squared, right? Conservation of energy says that whatever the shell is that you're going to contain that energy in, the size of the shell goes with the distance squared. So the solar energy decreases with distance from the sun. And there's also, of course, some fluctuations just in the sun's natural output. However, that's actually surprisingly small. The graph there shows the incidence of the solar irradiation at the Earth through all of the sunspot cycles. You can see there, the graph goes from 1975 to 2005, 3 of those cycles. And the change in that solar flux is only between roughly about 1365.5 meters square, watts per meter squared to about 3666.5. So the sunspot activity obviously changes that, but it's actually a relatively small change overall. And so basically, if you measure at the top of the atmosphere, we've got about 1366 watts per square meter of flux that comes to us from the sun. So of course, as it moves through the atmosphere, a lot of that is lost as by interacting with the atmosphere, it reflects off of the top of clouds because the Earth has quite a high albedo. And, you know, dust and whatever is in the atmosphere will reduce what you can get. But roughly at the ground surface, we've got about 1,000 watts per square meter as the amount of energy that the sun provides. What we then need to do with that, of course, is to convert it into electrical energy. And 2 things take into account there. The first one is Lambert's law. What that basically says is if you consider that diagram where you have this yellow beam of energy comes in, if it hits the panel square on, you get the 1,000 watts per square meter. However, if the panel is slanted, the width of the beam is still the same. You still have that 1 square meter, but it's now spread over a larger area. And we can show that that's basically goes with the cosine of the angle, right? So the area spreads out is 1 over the cosine, or you can also say that the efficiency per unit area is basically whatever you start with times the cosine of that area, and people will talk about that in some detail.
You can't tell that he has a degree in applied mathematics, can you?
This is RMHAM
I should say
University. I told you I'm
PhD in applied mathematics.
So
With the first love in
Nuclear physics.
Well, sure. So, of course, that's the energy that we get out of the sun, but now we need to convert that into electricity. So there's two parts that come into play there. The one is that the frequency of the light. Why are you pointing? Where's the question? Yes.
I is
Irradiance, right? So energy per square area. You need to convert that into energy. It is in part a function of the frequency of the light. So blue light has more energy in it than red light, just per unit area. But out in the sun, we actually get the whole spectrum, and our eyes have evolved to actually see that as light, right? So we're essentially taking the whole spectrum of the sun, and we're trying to convert that into energy. But then also, we're using the photoelectric effect on these panels, and so the efficiency of the panels of converting that irradiance to actual electric output is something that we can work on through our material science. And that's kind of what the rest of the talk
Hey, Willem,
will be about.
they say for every equation you put on the screen, you're going to lose half your audience.
Okay.
Which half of you are still with us?
I'm still here.
So, who's finding this?
Then
Well, I put it in here. I thought Willem was going to cover the theory part, but that's just fine. So, talked earlier about the photovoltaic effect, right? You'll hear that abbreviated PV pretty frequently. And that is basically the building block of a solar panel. So if we come over here to our demo panel in the room right here, see it's made out of these rectangular segments right here. Each of these constitutes one cell. And we put these into an array, and there you go, that's your solar panel. You can then take these, chain them together in even larger configurations, which we'll talk about later. And now you can start harvesting a pretty large amount of power from the sun. So these are semiconductor-based devices. If you're familiar with how a diode is made by combining some N and P-type doped silicon, that's basically what's happening here too, except that we kind of stretch that into a large flat area so that it can catch a lot of sunlight. And what's basically happening is when those photons from the sun, that 1,000 watts per square meter of flux, when those are hitting that panel, basically creating a pair of electrons and holes inside that silicon, and they start to move because of the energy that was imparted into them. And that's basically how we start getting a flow of current. We apply terminals onto the top and bottom of this sandwich, and that's, basics of electricity right there.
where's our? You
Yeah, I
want
can
to?
take that.
We'll give you the token.
All right, so there's a couple
In the
different
token ring here.
types of solar panels that are out there.
Speaking token.
One thing that's available these days are what are called bifacial panels. And bifacial basically means two-faced. So these panels are basically able to pick up, sunlight on both sides. So that might be useful if you mount these near the ground where there could be like reflections from the snow or some low-angle sun at the end of the day. This is not a bifacial panel, but if it were, you would see some more cells on the back. They're actually kind of transparent-ish. And it helps you get a little bit more light in marginal situations. This is monofacial. So we saw those cells earlier on the front. This is more typical. This is cheaper. And if you're mounting this on like a trailer or the roof of your house, you don't need bifacial because the back of the panel will be completely blocked by whatever surface you're mounting it on. So monofacial tends to be the go-to. Another distinction you're going to see if you look into buying some of these for yourself is mono versus polycrystalline. This refers to the manufacturing and the structure of the silicon wafer that's inside. Mono is more efficient, and that's the preferred these days.
Almost double.
Yeah, it's a huge increase. One way you can tell that it's monocrystalline is that if you get these like octagonal or shapes where they have the corners clipped a little bit, that's actually monocrystalline. It's an artifact of how they manufacture those wafers. Polycrystalline looks kind of like it's like a metallic finish. It looks kind of like a mineral almost. We don't have any of those up here, but there's a picture later in the slide deck of one. So we talked earlier about efficiency. This is a very dizzying chart. I admit that. But we don't have to talk about the details here. Basically, what we wanted to point out is that the best case scenario right now, and this is in lab conditions, there is a German team that has made a panel that's actually 47.6 efficient. That is amazing. Commercial panels these days, 20, 25%. So we're not quite there yet, but hey, it's free electricity from the sun. You know, who's complaining? So talking about an actual system here. So the solar panel itself is very useful, but it's not a complete system, right? We cannot rely on the sun to be there all the time. Clouds, other weather. The panel could be covered in snow and not work for days. So we need to combine this with a battery, some kind of energy storage solution. And in order to do that and charge that battery, we're going to introduce something called a solar charge controller. We're going to talk more in detail about each of these components in a little bit. But once we have this pathway here to basically fill up that battery with power from the sun, we can then add our loads. So whether you want to run household AC loads, you can add an inverter. If you're running radios and other DC appliances, we can get a regulator on there to start supplying those. And if you want to have commercial power in the mix, you can also add chargers to feed those batteries off the grid. So that's useful if you want to maybe buy cheap power at nighttime, or if you want to use this just as a backup, run full-time on commercial but have solar as a failover. There are a lot of ways that you can combine this stuff and to make an actual system. So we're going to go into more detail about all of this next. And I think at this point I'm going to hand it over to John for charge controllers.
Not online yet. People have asked if the slide deck is available. It is not yet, but when I quit talking, I'll put it online.
Oh, and he needs the speaking stick.
I have a speaking stick.
No, that's,
Oh, I need a button.
this is a token ring
I
network,
love
and you
buttons.
have the token.
I love buttons. Okay, so there are two types of charge controllers, and they are really dependent on what you're trying to do with them. In the case of what you see on the screen here, the first one on the left is a cheap, low-end pulse width modulation, PWM controller. It is simple, it's light, it's inexpensive, and it works, but is not the most efficient thing on the planet. If you're trying to build a Go kit for your amateur radio gear, a PWM controller is probably the right way to go, because it's less money, because it's lighter. Now, MPPT controllers are coming down in price, and the efficiency of those controllers goes up by a factor of 10 when you change to those. It takes what you're getting out of the sun, maximizes the charge current going into the batteries, instead of just turning it on for a second, turning it off, turning it on for a second, turning it off. The PWM controllers are very not smart. They really don't look at the state of what's going on with the batteries. All they do is put pulsed current into the batteries to charge them. In a situation where you're trying to do this at home or in a critical load like a mountaintop solar facility, we have one called Mosquito Peak. It's on Mosquito Pass in Leadville. There is no power at that location, so all of our equipment, the Colorado Connections repeater, the Rocky Mountain Ham repeater, and the microwaves that go through there, everything in that site is fed off of solar electricity. It is on a 13,500 foot mountain. It's not something where you could put wind in there and expect it to survive. If you put wind in that location, I would bet you that if you put it in the fall, it would probably not be there in the spring when you went back. It would probably have ripped it off the tower.
You just got to go to Fairplay to pick up the parts.
You would have to. There are a lot of manufacturers of PWM controllers on Amazon. you could probably get this PWM controller for $15. Yeah, not very expensive. They're readily available. If you're trying to build a Go kit, like I said, use it. It's fine. But be aware, you may have some noise issues.
I was
Now-
going to say, as we go through this, we're running these typically with a radio.
Correct.
And one year we showed up to field day and everybody had their solar and their chargers and their inverters. And I listened on 20 meters and basically it was S9 noise.
It can create noise.
So
Just be aware of it.
choose carefully.
You get
and,
what you pay for.
Yeah, you may have to modify.
So, like my comment at the bottom here, you get what you pay for. The MPPT controllers that are available now are fairly inexpensive. They're a little bit larger. They do get a little warmer. They're a lot heavier. But you're going to get a lot better product out of it with your charging system. Highly recommended to think carefully about what you're doing with it and how critical it is. So I pretty much already said that. If you're trying to build your Go box, PWM is going to be fine. When you're trying to build something for reliability or longevity, when there's no other power at the location, like a Mosquito Pass, like a Baldy and Breckenridge, where our other Colorado Connection RMHAM site is, you want to put a controller in there that's going to give you the biggest bang for your buck. Yes?
You mentioned
It should be on.
okay. The PWM is best for a Go kit, and if you're using it for
It's
ham
light.
radio, you're going to have noise issues.
You may. You may.
If you did,
So you could spend $15 on a device and have to send it back and try a different one that isn't noisy. There are ones out there that are not noisy.
okay. If it was noisy, is it ever cost effective generally to try to mitigate the noise?
I wouldn't even try.
Forget about
I
it.
just go
Just
buy a
move
different
on.
device.
Thank you.
Your time is worth a lot more than that.
Yeah, it's worth pointing out that each of these PLM controllers are going to have some different switching frequency inside, and that's going to affect the pattern of harmonics that come out. And depending on what bands you're trying to operate, it may be a non-issue, or it could be washed out, just like Doug alluded to earlier. One more question.
Go ahead.
So what, I've never found a charge controller that was worth messing with, that wasn't so noisy, was not worth messing with. So for field day, we found that same problem. And so what we did is I call it a split system. You've got a solar panel, charge controller, the battery over here charging, you're running on another set of batteries. So that's what we end up doing. And I've done that personally, is you just have two batteries, and that's the best way to get through that I've found.
Or
Oh,
buy
you're
a
saying
charge
you
con-
switch batteries.
Switch batteries, yeah.
And you
get
put
two
that
batteries.
solar far
Somewhere
away
away.
from your
As
antennas.
far as you can get it, practically.
So
Get away
that,
from you.
yeah.
'Cause I don't know any way to kill
So
it.
we have, pretty much everybody here has solar on their RV that we take to field day. We're using EP Ever Tracer solar charge controllers on our RVs, and they are parked at our site. They are pretty quiet. They work fairly well. They're not a cheap device compared to the other one. You're probably looking at a factor of 10 in cost to buy an EP Ever Charge controller that's an MPPT, built in a nice aluminum extruded box or cast box, completely enclosed, where the cheap charge controllers, they are not.
Now,
They're
one
in a
other
pl-
thing you can do is, and we'll get into this a little bit in the, I forget, Willem, what month it is, but we're doing one on antennas. Our first years, we had all the RVs and we had the antennas where they were essentially in view. Now, we've moved some of the antennas far away, others are directly above all of this, where there's really a bit of a null on the antenna. So just, if you have a really noisy charge controller like where Tristan is, don't have a Yagi aimed right over at
Yeah,
him.
not a good idea. It's going to hear it.
Yeah.
So there's a couple of options in here. Go
I had a
ahead.
quick question on the robustness. So I have a DC to DC converter and a charge controller in my overlanding vehicle.
Yeah, it's here.
I worry, like, if I disconnect and I'm tossing them around, like, do they
Not,
Up to that kind of
yeah,
vibration and-
they'll, oh yeah,
Okay.
absolutely.
Okay.
Not
I was
usually
just
an issue.
wondering. Okay.
So we're using, on our mountaintop sites, we're using Outback Flex and some Schneider Electric. That Schneider Electric controller that they have at the Mosquito site is a PWM controller. It's a $400 charge controller though, and it's built in a metal box. It's really designed for commercial installation. It's not inexpensive, and it probably weighs 15 pounds.
So PWM isn't old
No,
tech,
it-
it's just right tech for the right
It,
job.
it is old tech. It is the first charge controllers that were built. MPPT is newer technology, but it uses microprocessors to look at the voltages coming in, where the PWM is simply just, it's doing the same thing all the time, no matter what. It looks at the environment and determines what's going on in an MPPT world and sets the charge algorithm based on what it sees for solar output. It's just a lot smoother and better for the batteries. They're battery chemistry aware, so depending on what kind of battery you have, it does whatever is necessary for those batteries. Victron, absolutely phenomenal. If you want really high-end stuff, the blue Victron that you saw there before, it's great. But you're gonna pay for it.
I think we're going to talk about this a little later, but some of these, it sounds like your application is a vehicle that you're with. So you can go and push on the push buttons, but how do we deal with this up on Mosquito Pass, other than sending Mike Langhenry on his snowmobile up a 13er in the winter? A lot of these, we look for IP
The
configuration.
Outbacks that we have are fully IP controllable. Not only can you see the statistics live, because we have microwave to all of our sites, so we've got internet connectivity to every one of those sites, and I say internet loosely because we're not an ISP. We provide IP connectivity to all of our radio sites. It gives us the ability to turn things on and off, change set points on the controllers, turn controllers on and off, basically manage the whole thing to the point. No, those are very fixed.
Wow.
Because,
But
well, you could.
if there are mounts, and I think Dave's going to get into that a little later, you could potentially, but you're now doing a systems integration project because this is not really off the shelf.
Mosquito controls a generator. So if it were to get low enough, you could command the generator to start to charge the batteries back up. But we're currently running that site with no batteries. It does need a little bit. The site was built in the mid-'80s and it's in severe disrepair.
Mosquitoes not running with no batteries. We have batteries.
No generator, sorry.
No generator.
I
Well,
I
yeah.
misspoke. No bat. It has batteries.
Yeah.
Okay,
And
this
we
is,
will
this is
get
you?
into this in a little bit more. I think, did you have a question before we move on, Tristan, or?
No, I have one more
Or-
comment
yeah.
to say though, and that is that on our sites, we are UHF, VHF, and gigahertz microwave links, so we might not be as sensitive to HF noise on a situation like that than would be in a Go kit or at a field day site where there is a lot of HF communication going on. So it might not affect us as badly as it might affect you, is what I'm saying. I wanted to come up with a sort of analogy for what these MPPT controllers are actually doing. And this is what I thought of. Let me know if it makes sense to you. But basically, when we have a panel like the one over there, that's rated 100 watts. That's the max output that's ever going to provide. But that doesn't mean that I can necessarily, consume an arbitrary current from it and get that power, right? These are not perfect voltage sources. They actually get bogged down the more you try drawing from them. All right, so you get kind of like a curve like that, right? At this extreme right here, this is the open circuit voltage. That's no load whatsoever. You just attach a voltmeter to the panel. That's the highest voltage it's ever going to get you. All right, the opposite.
Which is usually in the middle of the winter when it's the coldest.
Yeah, there are test conditions standardized for this. This does get affected by temperature. But on the other end of the graph, right up here, that says ISC, short circuit current. If we take an ammeter and put it directly across the terminals of that solar panel, which is usually a safe thing to do, not in an array, but a small individual one like that, that is the highest current you're ever going to get out of that panel, okay? And in between, we have a curve. We multiply that voltage and that current, we get the power, right? And that power has a peak. That's the maximum power point, the MP and MPPT. So what that controller is doing is it's trying to optimize the current draw of your load to kind of get into that peak and provide the most amount of power to you. And so the analogy I thought of is, this is kind of like an antenna tuner, right? You wouldn't want to transmit your radio into a dead short. You wouldn't transmit into an open circuit. You have a tuner instead that can kind of dial in and get you that matching, right? Obviously, in this case, we're going the other way around. But that's basically what this controller is trying to do. It's optimizing the power that you can pull out from that panel. Any questions about that? PWM tries to approximate this by switching the load on and off really quickly to kind of modulate that. So it's not as good, but that's basically what these controllers are trying to do.
This looks like Dave.
Yeah, I think this might be Dave's turn here. So this section is going to be about how you can budget and size the solar system for your application.
Before we do that, I think the bottom line of this sort of introduction is that, two things. Number one is you get what you pay for. That you can do a really cheap solar source, but it's probably going to be pretty inefficient and give you a lot of problem with noise. The other thing is also, consider your application. If your application is that you need to haul this stuff up a mountain for a soda activation or something like that, then weight is really going to be a big issue. And, it's just like space applications where you probably are going to look for something that is very efficient for its weight.
Unless you have goats. If you have goats that will carry the stuff.
The goats will pay extra not to carry the extra weight.
But I've been called an old goat on the air, so I don't know what that means.
So, like everything else in life, there's a lot of compromises that you have to make in designing the system, and you need to basically choose whether you're going to optimize for cost or optimize for weight or whatever you're going to optimize for. And of course, as a segue to the next application is, what is it that you need?
That's really the point of this discussion is what problem are you trying to solve? What kind of equipment are you trying to power? And what we need to figure out is how many watt hours per day you need for each load that you have in your system. And then total those up and figure out how much storage you need. So you need to know the number of watt hours you need to store in your batteries, as well as do you have enough solar in order to put that charge back in again on a cloudy day. So you need to look at it all the ways. So start with power budgeting. Do an energy use audit. In this case, this particular slide is looking at an RV. So these are the typical loads you find in an RV. You got lots of 12-volt lights. In fact, if you have an old RV, they're all incandescent, so they're drawing many watts. First recommendation is upgrade them all to LEDs. In fact, there's a really good source for RV-specific LED lights, incandescent replacements. There's a guy that manufactures them specifically. And so sum up all the lights. Water pump, it doesn't run 24 hours a day, but it does run some number of minutes a day. So you figure out the amount of power it draws and then total up the number of minutes or what percentage of a day that power is required. 12-volt TV, any fan you might have, either just a whole house fan roof-mounted fan, or a furnace fan. Stereo, refrigerator, even though it's on propane, it has some 12-volt control logic and will have a certain amount of load required in order to keep it running. And there is a propane alarm and a CO alarm. And when you go in the basement and you do the master disconnect, it doesn't turn that off. So if you walk away from your trailer for a week and you come back, the battery's dead, if you don't have a way to charge it up. So this is an interesting one to keep in mind.
Wire cutters work really well for that too.
Yeah. And when I first got my trailer, I put it in storage, and I didn't take that into consideration. And after that, I went with a wrench so I could disconnect the battery, because throwing the switch was not good enough. I don't know why. So then do the same thing with any AC appliances you might have. How much inverter do you need? Inverter being conversion from your 12-volt batteries bank to the 120 that the appliances need. If you have an AC fridge, generally residential fridges in an RV are going to need 120. TVs and the usual stuff, microwave, coffee maker. Coffee maker is going to run for 10 minutes once a day, usually. So it uses 1,000 watts, but for 10 minutes in 24 hours. So computers, laptops, phone chargers, add it all up, and that becomes the number of, and this particular table, this is off of the GoPower website. GoPower being one of the vendors that you'll see referenced later on another slide. But they provide this table and they total it up in amp hours, and really it's a lot easier to think in watt hours, because that way you can convert it to 120 volts or 12 volts depending on which side of the inverter or charger you're on. So that's for an RV, and there's some really good references online for doing energy audits. I provided a couple of links here, especially on YouTube. There's some guys that are really thorough about RV solar deployment, and they go into a lot of depth. So, Tristan, you had a comment?
Yeah, it's a quick question. So what efficiency value are you using when you're modeling the loss from DC to AC conversion?
Well, of course, it depends on your inverter. That's in the spec for the inverter. They run 98% efficient, most of them. Yeah, the better ones do. And of course, it's not rough. I'm sort of out of context here, but don't get a noisy one either. That'll really ruin your day if you're trying to do POTA or field day. Now, the better way, instead of going to the label on the back of the TV and say, oh, this is 100 watts, it's way better to actually measure it. So get yourself some AC monitoring. A kilowatt is a really easy one, available on Amazon. There's a Chinese version that's even better. I have a power watchdog. A power watchdog is a gadget that plugs in line with your shore power. So when your RV is plugged into shore power, it not only, and it's got Bluetooth on it, so I can see the total consumption of the appliance that I currently have on. And it does totalization by day too. So if you're at a campground where you're paying for power, you can kind of keep track of that. It's also a surge protector, so if there's a lightning strike or something, it won't take out your trailer. In fact, it'll disconnect your trailer. So that's a good one. And for DC, the best thing is the battery state of charge shunt and monitor that we always install in line with on our solar power systems. And we'll touch on that topic again later on when we talk about products and products that are useful in deploying a system like this. But the state of charge, it shows you the current that's going into the battery, coming out of the battery, so you can get a good indication of what your current draw is really like. Now, on a simple backup system, it's a lot easier. You really just need to sum the idle loads. So let's say you're doing a repeater site. Well, you've got a microwave radio, you've got a router, in our case. We have a router, we have a repeater controller. We might have an all-Starlink node installed up there. And those are all idle currents. They're the same all day, every day, 24 hours a day. And then there's the on-demand loads. You key the repeater up. Instead of drawing 150 mils, now it's drawing 12 amps. But it's only doing that for, some amount of time per day. So once again, take the loads, add them all up, and then use that as your model for how much power you're going to need to store and how much power you're going to need from solar to charge it back up, or from some energy source to charge put the charge back in the batteries again. That's where the state of charge monitor comes in, because literally it's the state of the charge in the batteries. So, I did do that. It's more than the 20 seconds. Yeah, that was a lot to say.
On a serious note, we're just trying to
Understand.
plan this out for a break, so.
Okay. So we're gonna talk a little more in a bit about how much sun is available per day, and how to figure that out. And you got to worry about, gee, is there snow on your panels, right? Because anything that shadows your panels is going to take your charge to close to zero. So that's not good. And then, of course, we can talk about the power sources, solar panels, if you have a generator, wind, if it'll tolerate the installation. And on an RV, it's the tow vehicle. You'll see when we look at my project later that I have a 20 amp charger from the tow vehicle. So while I'm driving, it's charging the batteries. This one's fun, to tilt or not to tilt, exactly to your question. I've always been under the impression that it's somewhat linear, where if you got sort of winter and you got sort of summer, and you need to move it. Well, I proved myself wrong. Sorry, Doug, I was wrong. That's put one in your column.
What?
Having a different position on the panels for winter and summer. Not necessary, and I'll show you why. So Doug and I have had this debate a couple of times, and it's pretty typical. I mean, intuitively you'd think, well, it would make more sense to point at the sun because the sun's way up here versus way down here, but it's not really that different. And somewhat related, and we're not going to talk about, is tracking. Sometimes in some of the solar power generation fields, you'll see panels that not only rotate left to right to track across the track during the day from sunrise to sunset, but also from winter to summer, and they'll tilt the other way as well. And we're not going to talk about that. It's a pretty complex solution, but provides, you can't get any more power than that. But it's also, we'll see that it's not completely necessary. Looking at power in watts per square meter, as Willem introduced us to later, this is the maximum you can expect on the longest day of the year, right?
Not today.
Not today. This is the inverse of today. That's the maximum you can expect. And you can see the number of hours here from 5 a.m. to after 7 p.m. This is an actual reading from a sensor near my house. If you go to that link, you can see the data. And this was measured on this past June 21st. And you can see it's sort of a typical day, and it's up here about 1,000 watts per meter, per square meter, until it got cloudy in the afternoon. Briefly. That was the afternoon thunderstorm that always occurs at 3:15, right there.
This presentation has been posted now, if you want to grab it, off of rmham.org under course syllabus under Rocky Mountain Ham University.
Now, at the other end of the year, this is an actual reading that was taken. I didn't update the date, did I? But that's December 13th, I think. So it was last week. This is the total you can expect. And that's on a clear day, on a sunny day in the winter time, right? And, oh, there's another graph under. That shouldn't be there. But anyway, notice it only goes up to about 350, as opposed to the other one was at 1,000.
Yeah, it's a good comparison, actually.
Yeah,
You look at that and you see how diminished it is in the winter.
yeah,
It's
it really is.
significant.
Yeah.
So I assume that to be a fixed panel. It's one of my neighbor's sensors. Generally, it's a consumer product mounted on a pole, and they feed the data to underground. And then you can see.
The photo sensor under a diffuser. So it's just collecting all the ambient
Oh, okay.
measurement.
Okay, good. Thanks. So since we're at 40 degrees latitude, I looked at that number, and for 40 degrees latitude, this is the number of sun hours you can expect by time of year. Right? So from 9 hours a day up to beyond 14.
When you design, you better design for 9.
Yeah. On a cloudy day.
Yes.
Yeah. Or 4 days of clouds and a clear day.
I was going to say, it's more than a cloudy day, it's cloudy days.
Yeah. And in this part of the country, I mean, we're pretty fortunate here. We see the sun 300 days a year.
Yeah.
Right. But where I grew up in New England, it's the other way. Right. So it really makes a difference.
Unless you build a solar site on a mountaintop here, and then you're going to see sun probably less than you expect because of snow.
It is true. Though yesterday was pretty nice, a mosquito. And here's a link. This is a dynamic model on that website. You can actually go and you can try other latitudes and see what the numbers come back like. So this is a panel. And as you intuitively expect, you get the maximum collection of solar, or the concentration of solar, as Willem described, when the module is perpendicular to the sun angle. And then it changes as you tilt, or as the time of the year goes by, as the sun transitions from winter to summer. So, what about tilt? Well, on our RVs, we put the panels flat on the roof. And one of the reasons, well, part of that is complexity on an RV roof, having to climb up on the roof and tilt it, or push a button and have it tilt is a lot of work, a lot of complexity. And really, if you're using your RV during the summer, well, that's the maximum time of year for solar collection. In this case, the red line is the maximum amount of solar available that you can consume. And the green is with the panels tilted horizontally. So you can see in the winter it drops pretty low. But in the summer, it's pretty close to collecting almost as much as you can get. Now, tilt. Rule of thumb. set the tilt of the panel to the latitude. Okay, so this is the tilt set to 40. Look at that green line. That's the amount of solar you're going to collect on your module at 40 degrees tilt, winter and summer. You're almost as efficient as you can get in the winter, and pretty good in the summer, unless you need that extra little bit for an air conditioner or something. But that's not bad. And that was my point, Doug, was unless you need this tiny little bit over here in the wintertime, it's not worth tweaking.
Yeah.
It's probably easier to add a few more panels.
Yeah, to make up the difference.
And what Dave's referring to is he and I have been talking a lot about this, to tilt or not to tilt, and I was not wanting to tilt. I messed up Tristan here. I was not wanting to tilt, and we were thinking we might have to, so I'm very happy that with what we're seeing here, because when you add mechanical tilt, it just gets too complicated, and when it's too complicated,
It just won't work.
there you go. So,
That's a shout out to Scott Burkhart, W0KU. That's his saying. It's too complicated. It's just not gonna work.
Not gonna work. W0KU.
As we know. So, yeah, by the way, at this link, this is there's a live model. You can go and you can adjust the tilt, you can adjust the latitude, you can see what it does. If you go to almost vertical, the model will go to 80 degrees of tilt. This line actually flattens out all the way across, which you'd expect, right? Because in the summer, the sun is up there, but on a vertical panel, you're not getting a lot of power density. So, so try the model. It's really interesting, and it really helps you visualize the way the panels work and solar installation works. Who wants to talk about series and parallel? That'll work.
We'll make the camera guys have to work at it. So, when are we taking a break?
After the theory section, so it's this and then batteries.
This and batteries?
Yeah, that's right.
So, many installations that you guys have more than one panel. Should they be seriesed or should they be parallel? And why do you need to worry about that? What are the things that make you decide whether it's series or parallel? That's number one. Series, when you put them together, the voltage is additive in this world. You've got a panel in this example that is 17.5 volts. When you add those all together, you have 70. You're still at 8.6, which is the amperage of one of the panels. This looks like one array, but more volts.
I will also note this is at 25 degrees C,
Yes.
and we should touch on that at
Yes.
the end.
So your wire size with this probably should be 14 gauge, 15 amps, stranded solar wire. That's probably the best sweet spot for cost and whatever. Now, the next one puts us into a parallel example. Now, if there was more panels, this would be more apparent. But what we're trying to show by this, in a parallel installation, you're looking at 250 watts per panel at 38 volts, but the amperage is going to add up in this case. So you're going to go from what was in the last example, 8.6 amps running on a 14 gauge wire, to 32 amps here. 32 amps is going to take probably an 8 gauge wire, because 30 amps is the most you can push through a 10 gauge wire. Your wire is getting expensive now. Copper wire, only, in this case, only use copper wire for this stuff. Don't ever use copper-clad aluminum, the Chinese junk that they sell on Amazon. It'll say CCA in there somewhere. That's their little buzzword. Don't buy it. Doug?
You made a statement on the previous, use solar wire.
Yes.
Maybe
and
you should define
I will
that.
explain the difference between wire and solar wire here in just a
Okay.
minute. 8-gauge wire, good for 45 amps, good for a decent run. Cost of wire is very high now. The difference between 14-gauge wire and 8-gauge wire is significant. I just bought some for my truck. I got a new truck. I needed to get wire from the battery to under the back seat. It cost me 4 times what it cost me just 3 years ago to buy that wire. You really, really, really want to think about how you're going to do this. If you want to stay at a lower voltage, this is fine, but you're going to sacrifice that by wire size and how much it's going to cost you to do it. Fittings for the wire, the terminals on these panels are not huge. So it's probably better to go into a series environment to keep your wire size and your devices smaller so you're not having to buy extra large stuff.
I've heard people buy jumper cable and just cut to use it because that's usually coming in about 4 gauge if you're running it with your truck. Because it's a little cheaper.
I like, okay.
Sun exposure.
This goes back to insulation size. And when I said solar wire, the insulation on solar cable is about 4 times the thickness and the quality of regular electrical wire. Reason being abrasion. Here, this is welding cable. This is what I just bought a whole bunch of for my truck. That is multi-strand, and when they build these things, they recommend more strands because of surface effect.
Should I pass it around?
Go ahead. Surface effect at higher voltages, the current is going to travel on the surface of the wire. So the more surface area that you have, the less loss you're going to have. So if you're using a piece of solid wire, you're going to have less current transmission capability than you would using a piece of welding cable. That's why they use welding cable, because most of it is higher amps, lower voltage DC, and they want to minimize the loss at the end of the welding stinger. In the case of what we're trying to do here, hit the button again. I can't remember what the next slide was. I think it might be series parallel. Okay, series parallel. I'll explain solar wire here in a minute, but basically what it comes down to is you want to ensure that you're not going to arc through the insulation. And if you're running a series system, your voltage is going to be in the hundreds of volts. You could draw an arc off that wire 6 inches without trying. You can bring two of the, even 200 volts, you can bring them close together and it will start arcing at about that far away.
Well, if you're held onto both ends of the wire, you wouldn't be bringing them together.
You're not
You'll be
going to
lying
like
on
it.
the floor.
That's something that we're going to talk about in safety a little further. You can really get hurt by this stuff. When you start getting into the higher voltages, yes, the lower voltages are good and they will work, but you're going to pay more money for the transmission medium. The wire gets more expensive. That's really what we want you to see as part of this. Now, in the case of my RV, I have 2 arrays on my roof that are in parallel, but those 2 arrays have 4 panels each in series. So it is a series parallel system. You have one complete system, another complete system, and then by virtue of these devices, they're paralleled up for 2 different sets of arrays.
Is this like one's better for shade and one's not?
No, what I had is I had 1 set of wires coming down from the roof. And I didn't want to double the panels and put them all in one giant series because I would have exceeded the voltage of my solar controller. The solar controllers have a maximum voltage. that is critical to stay under it. Now, remember us talking about volts open circuit? That will come into effect with that here in a little bit. We're going to talk about what volts open circuit means to your charge controllers, because it will cause problems. I found out the hard way. And I actually went to Mosquito that time. I didn't make Mike go. Mike is our snowmobile expert, so I actually took the ATV with the tracks on it up to Mosquito to fix that screw up. So I learned that the hard way. You want to talk about the wire sizes here?
Thank you. Because we have panels in series, we can limit how high the voltage gets. So each string in this case is going to be 46 volts. It's just the sum of the open circuit voltage on the panels. And the currents the same way. So just like we said in the previous slides about wire size, you just need a piece of wire that's rated that can handle 22 amps. Your 50-watt mobile radio is going to use what, 12. So the solar on solar panels, the built-in wire is dependent upon the number of watts in the panel. My 200-watt panels have number 10 wire on them. And the
multi-strand.
And multi-strand solar wire. And the connectors, these are MC4 connectors or PV connectors, like the one he's got mounted right on the panel. These are meant for number 10 wire and crimp on very, very nicely to number 10 wire. And then, yeah, in my RV, and probably yours the same way, I had number 8 run from the roof to the basement that came from the factory that way. So I knew I needed to stay under 35 amps or somewhere around there. So, so at 46 volts and 22 amps, we're sort of optimizing the amount of power for the wire we have available to deliver it to the charge controller. So I was going to comment about shading. One thing about series parallel is if these panels are shaded, those aren't, then you'll get the current from those, and just this won't contribute. So it's actually a way to
it helps you average out shading.
Yeah. So if you park in a spot where the tree is over some of the panels and not over the others, as long as the strings are divided kind of strategically, then...
Shading and obviously cloud cover, right? It'll be more optimal in cloud. If you're traveling in more cloud cover areas, you'll get a little bit more...
Probably not in cloud cover. If you're talking about shading one set of the arrays, yes, but cloud cover is going to be everything. And it's just having more panels in a shaded time. The more panels you can put, even if you went out and bought some fold-up ones and stuck it under the, yeah, put some extras in there. Give yourself a little bit of extra surface area to collect. That's the best. All right, who has the remote? Safety. Oh, this is a fun one. So, I didn't write this, but this is something that's near and dear to my heart. Feel free to chime in. I think you might have written this, Tristan. Go ahead.
Yeah, actually, one comment I had about the previous slide, actually, there is another system. This is probably not something that you would use in a trailer or ham setup, but that's microinverters. This makes sense if you're going directly to AC, like in a home installation. They'll actually put an AC inverter into every individual panel, and those feed into a central bus. That gives you the ultimate defense against cloudiness over part of your system, because you can basically take individual panels offline. So that's probably something you would have if you get solar on your home. Probably not something you would put onto your RV, since you're mostly worried about charging batteries there. But yeah, John alluded to this earlier. The voltages and currents that you can evolve in a solar system are very, very serious. Okay, so you can draw arcs on the high voltage. If you have a large battery system and you make a short circuit, maybe it's only 12 volts, but if you're flowing hundreds of amps, that's going to splatter molten metal across the room. It will burn you. It can start fires. So please be really careful when you're working on these systems.
The rule of thumb for arcs on these things is it's about an inch for 100 volts. So if you have a 400 volt system, you could draw a 4-inch arc on it. So make sure you're thinking about that when you design it with spacing for conductors and other things.
Yeah, and we're going to talk about this some more in a little bit, but it also means that things like switches and distribution boards need to be rated for that voltage because like a standard household switch like the ones that are in the wall right here, they may only pull the contact a couple millimeters apart. That will not interrupt hundreds of volts of DC,
Yep.
so you can't
We
use
have a
that.
video
Yeah.
here a little later that's very graphic. You'll get it.
And then if we are talking about like home systems, please be very careful about how you connect that back into your home's wiring. Make sure you're never backfeeding the grid without having some kind of interlock device installed at your main panel. If you're getting an off-the-shelf like installed system, it will handle that. But do not do that nonsense where you're plugging things into your dryer outlet with like a male-to-male cord to get your house lit up. It'll get it really lit up if you're doing it wrong. Yeah, I think next slide is our. No, the video comes later actually. Yeah. Yeah. Okay. We have a decision to make right now. Do you guys want to hear my couple slides about batteries, or do you want to go to a break now for a couple minutes?
Let's finish this batteries, and then we'll go to a break.
All right. Any objections? Okay. I'll try to make this quick. All right. So far, we talked about the solar panels, the charge controller, basically everything that we need to get power coming into the system. Now we need to store that power somewhere. I mentioned earlier, we can't really rely on solar power being there at any moment in time. We have to buffer it with a battery or something like that. So obviously, we want rechargeable batteries here, and there are dozens of different types of rechargeable batteries out there. But we're going to focus on a couple of common types that you're definitely going to encounter as a ham or as the solar power type person. We're going to start off with lead acid. So these are ones that you have almost certainly encountered. This is like a medium-sized lead acid battery up here. They come in a couple different flavors. So the most basic and traditional is a wet or flooded battery. If you go out to your car, open the hood, and you crack the top of your battery off, which is something you should not do, by the way, you're basically going to see a little pool of sulfuric acid in there with some lead sulfate plates. And that is basically it. The acid is the electrolyte. Very, very old battery technology. It's been around for over 100 years. And it has some safety concerns, right? So obviously there is some pretty potent acid in there. And if you knock these things over, they can spill because they are not sealed.
And Tristan?
Yes.
The photos you have there are actually the old mosquito batteries, I believe. And those are actually, you can take the top off because they're little screw caps and put distilled water in when you boil them down.
You should.
But normally you shouldn't take the top off your car battery.
Yeah, so these traditional flooded batteries are things that you can actually maintain. And there are ports on the top here to basically get at each cell. These look like they are 6 volt, 3 times 2. So there's 3 ports on the top. And yeah, you can basically water them occasionally. They can also off-gas hydrogen if they are overcharged. So these are still the best thing if you want cheap bulk power storage. But we have evolved from this and developed sealed lead acid batteries. Popular type is called AGM, that stands for absorbent glass mat. And that's what this guy is right here. As you saw me earlier, I can hold this thing upside down, no risk of anything leaking out. They do have valves built in to relieve overpressure if necessary, but that doesn't happen very often. These are across the board much safer and are less likely to spill or off-gas or anything. That doesn't mean you shouldn't throw these things on the ground because obviously you can still crack them open. But a lot less risk if you want to use these for something portable, or like in toys and stuff like that. Another categorization of lead acid batteries that you're going to see if you're on the market, starter batteries. This is what you have in your car, all right? They're called SLI, starting lighting ignition. These are really good at getting a very large current going to crank your engine. But after that, they really expect to be put back onto recharge and let the alternator of the car take over. If you've ever left your lights on, you know how easy it can be to ruin your car battery with just a very small sustained discharge. All right. That's just the design of how the batteries are optimized, and it makes them very unsuitable for any kind of solar backup or ham usage. Despite the fact that they look really large and powerful. So that gets us into the deep cycle battery. Deep cycles are constructed to basically be allowed to be discharged for most of their energy capacity, recharged, discharged over and over again. The starter batteries, if you deep discharge them, that battery is probably toast. Or
You might get 2 discharges,
Yeah.
and then it's toast.
They really do not like that. Avoid at all costs. There's a third type of battery you're going to see there, marine batteries. These are kind of a hybrid. They're meant to be used on boats where you do need to have that like starter current to get your engines going, but you might want to shut them off and run like lights and appliances for a little bit too. I don't see any reason to go for that for ham backup. Just go straight for deep cycle. They do sell those in a lot of places where other car batteries are sold. If you specifically seek them out, they'll be marked pretty clearly. So yeah, that's it for the lead acid types. The other very popular battery technology is lithium-based stuff. So everybody here has a lithium battery in their pocket. I almost guarantee it. Lithium polymer is the go-to for portable electronic devices. Everything from cell phones to laptops, tablets, e-bikes. You probably have a dozen of these things in your house right now. They are everywhere, and they are very good in a lot of ways. We're going to talk about a comparison a little bit. But another variant of lithium battery is called lithium iron phosphate. And so this improves on some of the capabilities or drawbacks of the lithium ion or lithium polymer batteries. And they have a lot of advantages that we're also going to talk about in a little bit. I do have an example of one of those here as well. This is a Bio-Eno battery pack. These are kind of marketed towards hams for, Poda and soda. They are quite expensive, but they are pretty good quality. That's being passed around the room right now. And if you feel that, it basically, it's really lightweight. I don't have a good point of comparison for how much it weighs right now, but
What's the capacity of that one?
that's a 12-volt, 6-amp-hour battery.
6 amp hour.
I think it's 18, actually. Yeah, 18-amp-hour, 12-volt. This is hefty. You can come up and pick this one, or you can come over here and pick this one up, too, if you'd like. Yeah, if you are very conscious about weight savings, lithium batteries are going to be much better for you. We'll have a big chart where we can compare all this stuff in a little bit. Moving on for now, let's talk about charging. So all these different battery chemistries need to be charged in the way that's compatible with them. They all have their own little requirements. I'm not going to get into the specifics of each one, since that can get pretty long-winded. But the key takeaway is, get a charger that you can either like reprogram for particular chemistry. This one can do the various lithium types and also lead acid. You basically just punch it in on the control panel right here, what type you have, how many cells there are, and it can do the right thing. You cannot mix and match chargers, right? So a trickle charger that you might hook up to your truck battery to keep it topped off, you cannot bolt onto that little battery over there. It's a different chemistry. They have different charging requirements and curves and allowable charging input currents. Messing that up can, best case, ruin the battery, worst case, cause a fire of some sort. So really important to make sure that the battery that you have, you're charging appropriately.
Spending a few bucks on the appropriate charger is well worth the time.
Yes. Even if you don't care about fire risk or anything like that, you want to get the most life out of your battery, right? And treating it nicely is going to be the best way to do that. And Sort of on
Battery
that
Ge-
topic.
Battery Genius makes a charger that's fairly inexpensive and will do most any chemistry with the push of a button. They're available on Amazon. I highly recommend them.
All right, yeah, thanks for that recommendation. One other thing I wanted to point out in this category is that a lot of batteries, typically lithium ones, will come with some form of battery management system on board built into the battery pack. The one that's being passed around there is an example. So that battery has built-in overcurrent, over-temperature protection. Those are important safety mechanisms. Sometimes battery BMSs will even have chargers built in. And in that case, you can attach a straight DC source to that battery, and it will internally charge itself and cut itself off when it's done. Not all BMSs do that, so read your battery's manual to find out exactly what it's capable of, just so that you can use its features to their fullest potential and also not damage your battery in the process. All right, going back to our previous chart. Yeah, we got a question. Yeah, here, take the mic.
I was just going to mention that if you're traveling, that one consideration is you can't take a lithium-based battery on a commercial aircraft. You can take a sealed lead acid, but you can't take lithium.
There are limitations, but carry on, you can. Don't quote me on this, but I think the regulations are 100 watt-hours per passenger, 60 watt-hours maximum each battery for carry-on. Check bags, not allowed. There's too much risk of these batteries catching fire or something in the cargo hold where it cannot be seen. And that's a really, really big problem when you're 30,000 feet up in the air.
Yeah.
Don't quote me on those rules. Go check the TSA website or FAA, whoever is in charge of that, to be sure. But yeah, this is why the gate agents will tell you if you're about to gate check something last minute, take all your electronics out of it. Any laptops or those robotic rolling suitcases.
Yeah.
Have any of you guys ever had a lithium battery blow up on you? No? Mike has, I have, and it's not pretty. I had a very small cell from an iPhone laying on my desk, and it exploded on me one day, and it was a fireball that lasted about 5 minutes. It's not good. The lithium iron phosphate batteries are not as susceptible to that. The lithium polymers, dangerous. Definitely take serious care when you're doing anything to those.
Yeah,
if you were to poke a hole in your cell phone, if you somehow punched a hole through that cell phone or through the battery in the laptop, it will explode violently. It's not a good thing.
If you've been on a flight recently, you'll notice the flight attendants say, and if you drop your phone down in the seat, please call a flight attendant. Don't try to move your seat to get it out because they're doing that exact
They
thing.
get pinched and they explode.
So
I'm going to talk about battery swelling.
Yes.
okay.
If your battery swells, it's time to retire it. Take it out of your house or put it in a metal ammo can. I was listening to a couple of guys talking on a repeater yesterday, and the guy said, "Oh, my battery pack swelled up. I can't get the back on the radio anymore.
Get rid of
so
it."
I'm just going to use a rubber band." And it's like, no.
That would be bad.
That is not good.
So Tristan's going to go over this battery chart here, and he did a great job putting a lot of information. He's not going to be able to go through everything. You can't read the entire chart to us. But this is on the slide decks. Please go to the website. He'll go over the high-level pieces, but this really kind of says, where do you want to be? And why don't you take us through the high points, Tristan, because you're standing between the shark. This is a small episode of Shark Tank, and you're between the sharks and their food.
Yeah, don't worry, guys.
their
We're going to get
break.
to our break really quickly. Yeah, by the way, we call those swollen batteries spicy pillows.
Spicy pillows.
Yeah.
I call them footballs.
Football, spicy pillows.
Yeah,
This is
spicy
what I've
pillows.
Okay, but the Cliff Notes version of this chart right here. All right, so we have our lead acid batteries right here. These are kind of like your value options. They don't last as long. They are much cheaper. Where they do excel, though, is that they have a much broader temperature service range. These you can take below freezing, and they will still work. Lithium, that is not the case. In fact, it's actually dangerous to charge these batteries below freezing. So we have a cutoff here where it gets cold. This makes them not suitable for use in a site like Mosquito, where we have no conditioning over that space. Now, if you're talking about an RV and these batteries are inside the warm conditioned area of your cabin or RV, yeah, then maybe you can get away with it. But for something that's just outside an unconditioned radio site, we can't do it. We have to go lead acid. We have to deal with replacing them a little bit more often. We have to deal with the extra weight. Yeah, I think.
But those lithium iron phosphates that don't want to be charged, discharged at very low temperature, some of them have a self-heating function.
Yes.
Where does that energy come from? Maybe you could.
You have to pay for that
briefly
energy. It comes from your battery.
Yeah.
Sometimes you have to waste some of the heat coming from it to warm it up just so the chemical reaction works correctly. These are all chemical reactions happening, and that's why they explode so violently. We are basically taking electrical energy, converting it to chemical energy, and vice versa. And if we want to get denser batteries that weigh less and have more power in them, we have to make compromises and get more energy into those bonds, right? We have a question.
Yeah, quick question on the lithium iron phosphate. The cold applies to not charging or discharging, but if they're just set, because I think the DC to DC converters manage, if they sense the temperature, they will not charge. So that programming's reliable?
It's actually not the DC to DC converter, it's the battery management system in the battery. They will actually stop charging and discharging when it gets below 32 degrees. They will actually shut it off. Well, you know, your mileage may vary. If you got a good BMS, it's probably going to be fine.
Related to the quality of the battery?
Yes.
Okay.
Yeah, I did put the charging temperature in here since we're talking about solar backup systems. So this is the more conservative range usually.
I built heated batteries for my RV myself. I put rubber heating mats under the individual cells, and I control it with an external temperature control, and I don't let it get below 7 degrees Celsius. And it's fine all year long. But you're sacrificing solar power and energy from the battery to keep the batteries warm.
So that's just an extra measure, though.
Yeah.
You don't trust the BMS. It's back to your BMS.
I want my batteries to continue charging and discharging all year long. I don't want it to stop on me. So I created a way to keep it charging all the time. You can use, as long as the batteries are above freezing, you can use them normally.
Right.
So I just created an external way to keep the batteries above freezing.
So love your batteries.
Yeah, there was a comment from the website from K1PCS when we were talking about swollen batteries. It said Dell used to send you a replacement battery for a laptop still in warranty and then ask you to ship the swollen battery back to them.
Yeah.
Don't do that.
Great.
We'll talk about disposal in a second.
Just take a hammer and a nail and drive it right through the middle of it. You'll be fine.
I saw somebody once thinking they were doing like secure data destruction on a laptop, take a drill and yes, they went through the battery.
Yeah, so there's one more dimension to the comparison here, and it has to do with cost of ownership. You're replacing the lead acid batteries quite often, and you can only discharge them 50%. If you discharge them more than 50%, you're ruining the battery. My deep cycle battery lasted 2 cycles, I think. So cost of ownership was incredibly high on that battery. Whereas if you compare that to, we'll go down to lithium iron phosphate, you get 10,000 cycles out of those, and you can take them down to 80%.
And our cost column is probably those dollar signs were about a year ago old data. Now you can find some lithium, some LiFePO4s for virtually the same price as an AGM. So some of those $4 signs are down to 2.
They're
And then
under
look at the-
$2 an amp hour now.
Then look at the total cost of ownership that Dave has talked about. They really are good value.
So when you can live with the temperature constraints or live with you're generating the heat that you need to keep them in the operable range, you can store them down to -20, but you can't operate them below about 20 degrees. And you can't charge them below 32. So you got to live within the temperature limits of the technology.
So just one final comment while Tristan's getting the mic is in my final days on the Firestone Town Board, our building planning department came to us and said, we're going to initiate an ordinance that says you cannot store lithium batteries or even install within your residence, within the dwelling. They've got to be external in a metal enclosure. So depending on what you're doing, like John talked about them blowing up, and same thing, Dave and Tristan, you probably don't want to put a lot of lithium polymer batteries in your garage or in your basement, because if they go up, the whole house is going up. So
You're saying the polymer ones.
Yeah.
Because I have the lithium iron ones, and my understanding is they're very.
These are not affected.
how,
I just wanted to make sure.
how many of those do you have?
I have 200 amp hour in my RV,
Okay.
and then I have 100 amp hour as an auxiliary.
So,
private truck, 300 amp
I'm talking about putting 1,000 amp hours of
Okay.
these things in, that you're going to do something in your home. Just be cognizant of that. Your local land use regulations will vary, but, and so your mileage may vary, and the batteries in this case are included. So,
Yeah,
Tristan.
this is in the context of energy storage systems, which a lot of people are starting to put into their house, often in addition to solar. That's an example. The building code is starting to catch up with these things, and they have requirements now about where you can place these. It sounds like Firestone has a stricter ordinance than the standard one. But yeah, it's something to consider. Unfortunately, when you put them outside, that means now you have those thermal problems again. So now you're wasting money on heating those. All right, let's go ahead to our safety section, which we have already touched on quite a bit. We have lithium batteries all around us. The vast majority of the time, they are safe and fine. But there are some tips that we can follow to make them as safe as possible. And sometimes crazy things do still happen to them. So that picture up there is actually not one that I got from the internet. That is a ham friend's house over on the East Coast who experienced a battery fire in his basement. The battery chemistry was lithium iron phosphate. It was not charging or being used at the time. Nevertheless, it did explode and it burned out their basement. House was uninhabitable for a long time, had to move. Nobody got hurt, fortunately. But yeah, this stuff, you have to be careful with it. It's not common, but it's also something that's increasing in frequency across the country, and it is starting to get fire chiefs like the ones in Dougstown concerned about how we can mitigate this and how we can be safer about batteries. And so I compiled some tips that you can follow. So we talked about this earlier. Use the right charger. Overcharging lithium batteries is a great way to get them to go into that thermal runaway cycle. Protect your batteries so you don't also draw too much current from them. So as you can see here, this is lead acid, but those white housings right there contain some fuses to make sure we don't pull too much from here. This one has an internal VMS that cuts off on overcurrent applications. So whatever you're using, make sure you have some kind of protection installed on that battery. And yeah, here's a circuit breaker. This is for if you have like a really big battery bank. This is probably 100 amps or so, 120 amps. This is a big one. You basically bolt onto that with those really large crimp rings that we have over there.
Be aware that that one is a Blue Sea breaker. There are a lot of Chinese manufacturers of breakers on Amazon, and your mileage may vary. I highly recommend Blue Sea breakers and not the Chinese breakers.
And the Chinese ones look just like this. But you'll also find, is it Bussman or?
Bussman is good.
They're good. And the
Blue
Chinese
Sea-
ones look exactly like that.
Yeah, I think they ripped off and duplicated that breaker. It'll come and it'll look just like it, but it probably should say Blue Sea on it if you're going to buy it.
Yeah, and that leads us to the next point, actually, which is buy your batteries and equipment from reputable sources. I know that everybody is trying to save money these days, and sometimes that deal that's too good to be true may actually be, especially from these overseas sources. You'd never really know what the quality control is like. They could be peddling batteries that came from a reject pile from some other manufacturer. They could be skimping on the insulation or mechanical robustness. A lot of times when these batteries do fail, it's because something mechanically inside broke. Something that should have been separated no longer is. And that can also trigger that runaway reaction to start. We did have one question here from the back. Let me hand you a mic.
So my understanding is you want DC-specific breakers. You don't want to just go get a nice square D AC breaker from
Correct.
Home Depot and plug it in. That's not going to do it.
So
No.
let me bring up a little comment about that. Square D does make a DC capable breaker, and it is called a QO. And it's an old style breaker that's still available today at Home Depot. And if you're trying to get a DC breaker for a reasonable cost, Square D QO is the only DC breaker that they make. They also make a Homeline product. That is not what you want. You want Square D QO if you're trying to do it with stuff from Home Depot. If you have time and you can buy it from Amazon, Blue Sea is, yes, they're a little more expensive, but you get what you pay for.
I want to keep us moving, but if you want to save some money, you can get those QOs and take the money you spent on savings and increase your homeowner's policy. That way, when your house burns down, you can replace it all. But seriously, don't skimp on this. There
buy
are
good
places,
stuff.
it's like my cousin who's an ophthalmologist has a picture, little plaque in his office. It says, never look for discounts on eye care or parachutes. And this is similar.
Yes.
Don't take shortcuts. You'll regret it.
I've got one comment from, online from Ed, K8JMB, JMW. Sodium ion batteries can be charged/discharged down to minus 20 degrees C.
Sodium ion
That's what it says in the message here.
must be
Yeah.
a new tech.
Like I said earlier, there's dozens of different types of rechargeable batteries out there. We could spend all day here talking about them, so feel free to do research into these and see if they work for your use case and if you can obtain them. Just for the sake of time, we were focusing on lithium and lead acid-based batteries here.
Wrap us up here, Tristan.
Store and charge it safely. This means don't plug your laptop in and then shove it behind a couch cushion. Make sure there's airflow and everything to keep these batteries at a safe temperature. Protect it from that mechanical damage. Tape up your terminals just so that nobody can drop a wrench onto your system. Big deal if you have a larger battery bank. And then finally, when you are all done with that battery, if it's past its useful life or if you're worried it may have been compromised, there are safe ways to dispose of this. So a lot of battery stores like Batteries Plus will basically just take them for free. You can just drop them off and they are equipped to recycle those properly. Your town may also have a drop-off location, some sort of recycling center.
Home Depot does
Okay.
smaller batteries.
Home Depot does it. Okay, yeah, I've seen it at Lowe's too. They'll have a box that you can put it into. Sometimes auto parts stores will actually give you credit for a lead acid battery. There's actually a deposit on those things for the core charge. You can get that back if you recycle the battery. It's like $10 or so.
Check with your town and county, because like in Weld County, you can just bring them there on the day and they'll take them for free. So
Yeah.
you don't get the
Please
core
don't
charge.
put these into your normal trash. And
No.
Please don't put them in your basement and forget about them for years.
Another note on safety, we had a presentation by James Sizek, KI0KN, previously, I think about a year ago, on battery charging and technologies. He's got some safety in there. That should be on the website.
It is on our website.
Go look it up. It's a great reference.
It's 2.5 hours on everything you ever wanted to learn about batteries. It's phenomenal.
There's also a good website called Battery University that has some really good information on it.
Yes, audience recommendation, Battery University is a website that has a lot of good information. We actually referenced that quite a bit when we were putting together these slides, just to double check our sources. Yeah, so with that, that is the end of our battery and solar theory section. So when we come back, we're going to talk about sort of off-the-shelf products in some more detail, actual components that you can go out and buy to put together to make a system. Okay, welcome back. So for this next half of the talk, we're going to jump into off-the-shelf products, basically actual products that you can go out and buy that either we have worked with or have experience with that allow you to build these systems for yourself, whether it's for an RV or a small portable system you take with you. So let's go ahead and start off with the panels. So there's a couple ways to get these. One is new. So we talked earlier about the cell types and whether or not it's bifacial or monofacial. In the interest of time, I won't go over that stuff again right now, but some manufacturers that we have bought from the past include Seitan Solar and RMHAM. This is a RMHAM panel right here up front. If you ever want to come take a look at this. They're pretty good and well priced. Do you have any other comments on manufacturers to add in,
This
John?
list is not exhaustive.
No, it is, it is not exhaustive. There are so many manufacturers of solar panels right now. Your best bet, find yourself a good monocrystalline panel. Go to Seitan Solar. You can buy used or new there. Easy, straightforward. Pick something that fits your needs.
I bought them there. They're phenomenal. I think I got it for $65 a few years ago. I got 290 watt rigid panels, 2 pair, and people were just like loading the back of their trucks up with them. I think that I think the price has gone up though.
Not significant.
Seitan.
Surprisingly,
You
not
just pick 'em up in
significantly.
Arizona, load up the truck.
We ordered them from there from Santan when we built Mosquito, and they were, last time I checked, about $60 plus another $10 a panel to ship them here. So, and I think we ordered 15 or 20 of them.
Used ones, right?
Yeah, used ones.
Yeah, it's a good deal.
Yeah, well, speaking of used, oh, sorry, Willem.
Yeah, this doesn't mention it, but you can actually buy some pretty flexible panels too, that's not rigid like that. That's good for like RV installations.
RMHAM has those.
I have a 200 watt RMHAM on my, I just installed them, they're the best. And I have 3 100 watts on my truck, they're phenomenal.
Yeah.
And they actually, I've gotten 100 watts plus out of them, completely horizontal, which is amazing.
That's good.
Yeah, we meant to have a foldable panel here for a demo, but unfortunately it was not accessible in time. But yeah, basically it's usually embedded in some kind of fabric that you can then fold out and then fold back up for storage. So a lot easier than carrying something like that on your back. Okay, so the used department, you can save a lot of money by getting a used panel. So solar panels themselves have a pretty long lifespan. They can last upwards of 20, 30, maybe even 40 years. As long as something hasn't, hit them or they haven't been mechanically destroyed. So one thing that has changed over the years is that the efficiency has gotten better. So if you are saving money by going out and getting an older panel, you might not have the best efficiency in the market these days. But if you're not space constrained, you can make up for that by just having more of them. Snail tails are a kind of manufacturing defect that you can find in panels. A lot of people don't like the look of this, but it has little impact on its actual power output. So that's an option if you want to save money but get a effectively new panel.
You're probably questioning, why are there so many used panels? If they're good panels, why are people getting rid of them? And I'm not totally sure the answer, but I believe there's grants out there, there's commercial operations that just say, we're blindly swapping these out. This is a good deal, and let you move on, Tristan.
Yeah, one question?
So one source, I've got a ham radio guy, a buddy of mine who is an electrician, and when you default and not pay for them at places like Sunrun and those kinds of places, he actually goes and gets them off of people's houses.
Okay.
They don't want them back.
Yeah.
So I have not been lucky enough to gather some of those, but that's another source.
Sometimes a used car is not a good value. They're selling it because it was a lemon, and other times they are. So
Yeah, so this is a stack of panels I came across for sale at Resource Central in Boulder. They're kind of like a construction thrift store. Whole pallet there. I forget how much they were each. But if you're resourceful and you're looking out for this kind of stuff, you can find it for pretty cheap. And those were not small panels. They were like 250 watts apiece. So when you're shopping for panels, this is how we can analyze some of the information on the back. So right here, 335 watts. That's going to be the maximum output of that panel in best case conditions. All right. Below that, we're going to see two other values, VMPP and IMPP. Voltage, current, maximum power point. So if you multiply these two together, you're going to get that 335 watt value. That's basically saying in optimal conditions, if you draw this much current, there'll be this much voltage across this panel. Power is voltage times current, 335. All right? Below that, we have those two values I talked about earlier, right? The open circuit and the short circuit current. Sorry, open circuit voltage, short circuit current. Those are the two extremes on either end. You wouldn't really be seeing these in normal use, but they go into factoring system safety equations. Speaking of which, 1,000 volts right here, that's the maximum series voltage. So if you're putting a bunch of these panels into series, which is how they normally would be installed in a house, basically it's saying that that value, 41 volts, times the number of panels in series cannot exceed 1,000. That's the safety limit. And
Hold on, let me say one thing towards VOC.
yeah,
Volts open circuit is very critical when you're designing a solar system. Your solar controller can take a maximum voltage. That maximum voltage is usually figured on how much voltage the panel is going to put out. The volts open circuit is on the coldest day of the year. It's gonna go up by 10%. So make sure you're thinking that when you do it, use the volts open circuit voltage additive on all of your panels to design how much solar controller you need. A lot of the EP-Ever charge controllers take 150 volts in. If you exceed that, the thing will just shut off. Don't overthink it too much. Just figure out how much it's going to be on the coldest day of the year.
yeah. So those two numbers, those are basically what you're going to factor in for safety. If you need to gauge, or size your wire gauge or the controller voltage, those are the numbers that you'll be using because they are the worst case measurements.
Victrons have controllers that'll go up to 450 volts now. Just have to take that into account when you do it.
This is the connector. It's called an MC4. Basically, every panel these days has this attached to it. We passed around a lead earlier that I think has one of those on there. Great, you got to see what they're like. They are waterproof, UV resistant, and they are designed to handle pretty high voltage. Do not disconnect them when they are live though, because otherwise you're basically going to draw an arc as you pull those contacts apart. So the system needs to be shut down before you touch any of those things.
Notice the comments down here.
Yes, John added these very important tips. So these are usually crimped. Make sure you have a good crimper that doesn't allow that wire to move at all inside the connector. You really have to make sure that that contact is clamped down tight. I suppose you could also solder it.
I've soldered,
better, right?
when I did the solar bunkhouse, all of those were soldered because of vibration resistance. That's really the only reason why.
Okay. All right, yeah, so if you have a vehicle installation, consider soldering then. We actually will have a slide about that solar bunkhouse project at the end of the presentation. It'll be one of our sample projects. All right, I think I'll hand back over to Dave or John for this section. We already covered a lot of this content earlier in the presentation, but here's some pictures of the mosquito deployment.
Were you going to do this one, or do you want me to?
Go for it.
Okay. So, yeah, we talked about charge controllers, and this is mosquito. We've been through all of this, so I'm going to go kind of quickly through this because after this, we have Dave's example of the RV trailer, and it's really good what he did, so I want to leave enough time. Does anybody have questions on controllers? I think we've...
Order of installation, I thought like battery first to the charge controller, and then literally are you covering your panel before you connect?
No, you don't have to cover the
I'm going to ask you
panel.
to hold that one, and we'll get to that with, maybe Dave can put that in his piece. So,
The orders always hook the battery up first.
So, yeah. So AC inverters, we've talked about, they're not all created equal. I'm sorry, is there? Okay. Some of the brands that we like, again, stop me if you really have questions. And we talked about batteries. Tristan gave a great analysis of these. Probably you're going to be moving towards LiFePO4s, but you look at those charts. The piece that we really wanted to get into is wet batteries. Has anybody in this room actually filled these batteries?
Yes.
But these actual ones are Calcon,
Yes.
and Dave Blaylock over there has watered these many times, and you guys have done them. So these
You have to
are,
stop at the fill ring.
yeah, these are sealed. We actually have some of these on Mosquito, Squaw Mountain, other places. But if you're doing a solar thing for your house, you may look at these rack mount. The thing I like about these is you can mount them in a rack cabinet. It's a lithium technology, but it's inside a metal box. So you've got a little bit more protection if something bad happens. So just take a look at these.
We also have some open frame rack mount battery shelves that I think are in the comm trailer, and maybe also your RV, but I'm not sure.
Mine are in a box.
Okay, I couldn't find a good picture of one of those, but I think they come from basically telecom suppliers, telecom racks.
There's all sorts of form factors, and we just wanted to kind of show you some of the basics. We didn't talk a lot about DC to DC, but John,
Yeah, so there's two applications for this. If any of you have a brand new vehicle that's got like John has, that's got an alternator that varies its voltage all over the place, because in order to optimize fuel efficiency in the truck.
Yeah, it could be anywhere from 8 volts to 20.
So do you really want to hook your radio up to that, and how many radios will actually run? Well, one use for one of these is to take that variable, that wide-ranging voltage input, and give you a nice solid 13.6 or whatever you want out the back. In my trailer, what I use it for is to isolate the power system of the tow vehicle from the trailer. So I've got 14.5 volts of charge on my lithiums. I don't want to feed that back into the tow vehicle when I plug in the trailer light plug.
These from Victron are also multi-chemistry, so you can switch them for different batteries too.
Absolutely, and there's two versions. There's a non-smart and a smart. The smart's got Bluetooth, so you can watch it. The other one's just got a pretty green light on the front.
So these are basically chargers without the solar intelligence,
Right, this is just DC to DC, so this is from one for example, let's say you had a Class A motorhome, right, there's no trailer, but there's a starter battery and there's house batteries, and they put one of these in between so that when the engine's running, you can charge the house batteries, but when the engine's not running, you won't discharge that starter battery. So it's for isolation as well.
Yeah, I know a lot of hams do that. They basically put a second battery into their car for powering the radio, so they can leave that on when they're parked somewhere, or protect that starter battery.
or our Rocky Mountain Ham QRV vans. We don't want the engine start battery to discharge when we're sitting there at field day running a pileup and not paying attention. So, we good? Okay. Okay, I don't know how we start this, but
I think we have to click on it. Whose laptop's it running on?
I think it's right up here. I think Tristan found this one, but
I found
this
that.
is or John found it. It's a nice thing but before he gets this started, be thinking about how are you going to put this fire out?
It's really hard.
Do we get audio or?
There's no.
There is
sound for this,
audio.
but
There's audio on it.
That's his shut-off switch there that he just held up. Now watch this. That's what happens.
See how fast that went up?
That's an instantaneous arc fire. I mean, it literally The only way to stop it is to kill the current into it, and he just cut the wire, and it pretty much went out.
Yes, I should point out that switch started on. He turned it off. That's why the arc started, because it pulled the contacts apart, but the current ionized the air between the contacts and continued flowing.
Yeah.
That's ugly. That's what you need to worry about in high voltage solar systems.
So you've got to shut your power down. If you do use an extinguisher of sorts, until you shut the current down, it's going to keep burning.
Yeah.
But don't use water if you are going to use something to, after it's done there, just use a dry chem.
Yeah, obviously this is going to be something that's fixed and installed on a wall somewhere, so you can't just like remove it quickly. But for the battery fires we talked about earlier, typically the best way to contain those is to have a metal bucket with sand and a cover. Wipe it in there with some very high temperature gloves, smother it. That's the best way to get those things to go out.
Yeah.
The-
Okay.
The one place you can really run into problems is with circuit protection. This thing is 120 amps, but it's 48 volts. Don't use it on solar panels. They
Yeah.
make solar panel DC breakers. I'll show you a picture one when I put my pictures up. Make sure you buy the ones rated for
Yeah.
the voltage that you need for the solar panels.
And as I said before, if you want to buy the cheap one, put the extra savings into your homeowner's policy. This thing is not. What'd you do, Tristan?
might
You
need
broke
to click
it.
out of that video.
Ah,
Yeah, there you go. Next.
there we go. Okay, so we've got some small scale that Tristan put. Would you like the talking stick?
Yes, please. Thank you, Doug.
So what we're going to do next is we have a few field examples. I think that we've been really good about interactive here, but this is the most interactive part. We have some small, medium, and large. Tristan and Chris have some info on this portable. Dave has a really great presentation on what he did to his RV, which you might actually do. We do have the Rocky Mountain Ham bunk trailer and the mosquito site, but I'm guessing you're probably not going to build one of those. So we're really going to put the time into this and Dave's, and we'll fly through the other at the end, and then we'll also have some time for interactive. So.
Yeah. All right. Thanks, Doug. So I wanted to also cover some smaller scale installations. It's great if you can bring solar with you on a trailer or have it full time in your house, but sometimes you want to go camping and there's no power available, but I want to run my radios, right? So this is a system that I use a lot. It's centered around this guy right here. So this particular model is discontinued and not available anymore, but you can still get stuff like this from a lot of different manufacturers. These are basically called solar generators or like power banks, but basically what this thing is a large battery. In this case, it's 1.2 kilowatt hours, so quite a bit, yeah. And it has a couple different inputs, and yeah, we can slide this out of the way so you guys in the left can get a look. We got a couple of different input types, and we have a bunch of different output types. So to put power into this thing, you could start off with the AC/DC adapter, just charge it at your house, keep the battery topped off. It also comes with a cigarette automotive port, so you can charge this while you're driving. And since this is the Solar Talk, it accepts power from a solar panel. This has a built-in charge controller. And with the help of a cable like this, you can actually directly connect solar panel to one of its DC inputs. It'll take care of all the voltage conversion and charging. And here we have our two MC4 connectors that connect to the panel over there. So on the output side, we have AC, so it's got an inverter built in, 120 volt. Another cigarette port for your 12 volt output, some DC, then also USB. This particular model is actually really nice because it has power pull for the input and output. So that's great for plugging into ham radio equipment. The only annoying thing about it is that they reverse the order of plus and minus. Yep. So I have a little adapter cable that crosses them over. the colors are correct, but they do have positive on the right here if you're looking into the connector. So almost there. But it's still really useful. And so you can see in the pictures in the background, I set this up on a table at campsites. I even have the roof mount rack that I built for my car out of some strut channel to basically mount that thing while I'm traveling. Very useful. If you're doing things like charging laptops and phones, this will get you through a really long time. If you are using some heavier appliances, maybe you want to look into getting a gas generator to run occasionally. But yeah, you could easily charge your phone and maybe even laptop like a couple dozen cycles off something like this.
In your photo, you've got is that an HF radio?
That's your HF radio.
Oh, that's my HF
Yeah.
radio. So, you know,
That's the one I borrowed from you.
how long do you think you could run HF, assuming we reset the HF radio so that it actually transmits?
Yeah, that was not a fun thing to discover.
But you know, could you run a whole field day with this battery, or probably you would want? Could you go overnight, maybe?
Oh yeah, certainly,
an extra
certainly a
charge?
good day.
Okay.
Right here, it's hard to see. This is actually a little power meter that I had attached to the circuit just to characterize how much current the radio was drawing. But unfortunately, I don't remember the numbers. This was a couple months ago. But just operating for like one evening didn't put much of a dent into that battery. I'll just say that. It claims it's a pure sine wave. I have not personally looked at it on a scope, but it's going to be a lot better than those cheap travel inverters that they make for your car. Yeah, unfortunately, these things are not cheap. This one is not for sale anymore, but there are a lot of other brands out there that make things like this. But you are looking at like $800-900 or so, and then if you want to get their solar panel, that costs extra. This 100-watt panel from RMHAM, I think, cost around $100. Don't quote me on that, though. Yeah, this is still too big to carry up onto a mountaintop if you're doing like a PODA activation or something like that. So in that case, I would go back to something smaller like this. You don't always need to be running off solar. You can always use solar just to sort of top off batteries that you already brought with you and stretch their runtime. Kind of like what you were alluding to earlier, where you can basically take two of these, have one charging off in the distance, and then you can swap them out, have that ready for nighttime, continue operating. Again, we don't have it here, but we do have a folding solar panel, which we actually did use out in the wild for a real deployment. Got a picture of that here. Kind of see it stretched out over the rocks right there. I don't know if they have the correct tilt angle on that, Dave, but I think Chris did a good job. Yep. So RMHAM used to basically provide communication support for an ultra marathon at Golden Gate State Park. And we had these aid stations throughout the course. This is a very mountainous region. You can see the contour lines are all over the place. There was one central point that we could set up an access point to get IP, get microwave out to all these different aid stations. And that's this spot, City Lights Ridge. There are no services, no power, no road. How do we handle this? So we deployed Chris. He's got all these microwave links, laptop, solar, small battery on his back. He hikes up there and spends 36 hours there keeping the system up and running so we have connectivity for the whole event. And here's Chris if he wants to add more.
Sure, I could talk about this. So this was a really fun event to support, and it's very sad that we don't get to do this anymore. But yeah, we would have a team of about 5 folks, luckily, to help me pack all of this gear up here with the tripod and several microwave radios and all the power gear. This was a pretty extensive operation. But of course, what we were optimizing for in this case was weight. We cannot afford to have heavy lead acid batteries, so whenever possible, we opted for lithium batteries. We could not afford the extra weight of MPPT charge controllers. wasn't really necessary for us to get the optimal power, just as long as we were getting some power off of the panels. And so we would opt for PWM charge controllers, the cheaper, lighter ones. And that's the way that we ended up running this. In theory, the batteries had most of what we would need for, the event. But we definitely wanted the solar there as, being able to top off the batteries throughout the event so that we didn't run low.
Remember what wattage you were getting off those panels?
I believe we had 60-watt panels on the side here. What's that?
Not bad.
Yeah, it was really good. And then the last year or two, I was able to borrow gear from John. There was a fold-out panel, flexible panel in canvas called a power film, and that was very nice to have. I think that panel was 120 watt, and that provided me with sort of my own like laptop battery, as opposed to we had the separate system still for just the microwaves. And so we had the two separate systems in order to make sure that I didn't kill the microwaves and the microwaves, make sure I didn't draw too much power with my own needs.
Now, Chris,
Yeah.
you're talking about the microwave up there. In this particular event, if you're ARES in the room or online, this was kind of a non-traditional ARES Auxcom deployment because we were using 5 gigahertz ham radio frequency microwave, or 802.11, rather than the typical shack on a belt or high power FM radio. Very power efficient, but we weren't powering that kind of stuff. All this was for is that efficient lower power microwave.
Right, exactly. Those microwave over IP radios, I think they're 100 milliwatts maybe per
Yeah.
radio, and we had, 3 or 4 of them up at this site, but it was still optimized for low power draw. We did not have a repeater up here because that would have been very power intensive. And so the only thing we had up at this site was the very low power stuff.
Which we were sending large volumes of data, or you can think of it if you're an ARES group, sending forms of material through amateur radio. So if you're an ARES group, think out of the box. Everything is not a Baofeng portable reading it on voice. You can do incredible things with fairly lightweight stuff like this.
Yeah, for sure.
Lightweight equipment.
Yeah, and I want to point out one other thing about this particular setup. A lot of people are saying, well, why do we need this when we have Starlink or satellite radios available? We have a lot of those. They would not have worked in this case because a lot of these sites are in canyons. Bouncing through these different hops to get to Chris's site and then to one of our points of presence on Thornton Mountain afterwards was the only way this worked. So there is a lot of value in being able to do this kind of thing if you need to support a certain served agency with digital or IP connectivity.
Questions about this particular setup? This was a lot of fun.
I was just gonna say, PowerFilm makes really good stuff. They do a lot of government contracts and high-end stuff, but the average guy, they're kind of out of the price range.
That's true. A comment from the audience said PowerFilm is great stuff, but it's very expensive, out of the price range for most of us hams. There's actually other brands, and you can find them on Amazon that are much more reasonable. John just earlier today showed me there's a similar canvas, flexible, 120 watt panel that is around $300. So that is getting more towards what we can afford. Yeah. And you can find deals on eBay and stuff for the PowerFilm if you keep an eye out.
Thanks so much, Chris, for jumping in. All right, I think now it's time to hand back over to Dave, and he's going to talk about his brand new RV solar build. So a lot of fantastic info about a real-world installation with some pretty large panels and large battery banks. So over to Dave.
Okay, thanks. So I'll preface this by saying my wife retired in the day after we got a trailer. So that kind of set in motion the whole process of deciding what to do about getting a trailer. And after being at Field Day and looking at what John and James had built for solar power systems in their RVs, I caught the bug. And hey, it's a fun project. It's a whole bunch of parts you get to plug together and do something useful with. John started me off with a shopping list, so it kind of gave me a good starting point, and from there it exploded into, so this process, I'm going to show you a whole bunch of pictures, and there's also a whole bunch of links at the end to various YouTube videos from people that I trust that are providing good information that can be a good reference. So my goal was to provide off-grid operation for things like Field Day. I needed to provide lighting, wanted to run Starlink. I wanted to be able to run the furnace and the fridge, which the heat comes from propane, but I need enough 12 volts in order to run the control systems. And the water heater control, again, it's propane, but I need the control system running. Didn't plan to run air conditioning on it, though it's capable, and it's untested at this point. And really minimal 120 volt appliances, mostly a couple of TVs, one at a time that don't draw a lot. The RV itself is a fifth wheel. It's a 31-foot Jayco Eagle HTX, and it has limited roof space. And what I mean by limited is there's a lot of stuff up there. It's 2 air conditioners. There's plumbing vents. There's a microwave. I think the microwave exhaust vent comes out up there, the refrigerator vent. And I've got a picture without all the panels on it. And the Jayco, got a sticker right on the side, pre-wired for solar. And the pre-wiring went from the roof to the charger location.
Their charger location.
Somewhere. My task was to find what that location was. It was undefined, and I couldn't find any references to it anywhere where they tell me where it was. And then there was pre-wiring from the roof to the front bay where I intended to install all the power. I had that end. I had the roof end. I didn't know where the middle was, so hence the story. This is what the roof looked like. I also have a whole house fan, 2 air conditioners, the ladders on the back, plumbing vents. There's a TV antenna over here on the side. And I needed to be able to service things like air conditioners. So I needed to be able to walk through and buy things. I started out by taking measurements of the roof. I was telling the story this morning. There's a video online of a guy that did the same thing in a 46-foot trailer. What he did was he cut a piece of cardboard the size of a solar panel and put it on the roof. And then he sent his drone up and got a roof shot of the trailer. And then he put that in a paint program. And he grabbed the cardboard image and he placed it on the roof, trying to figure out how many panels he could put and where he could put them and in order to do it. It was really clever. I wasn't that elegant. I'm up there with a tape measure. The part of the pre-wiring is GoPower provides this roof gland. It's a waterproof interface with these MC4 connectors on it. So it's the same connectors that are on all the cables and on all the panels, and all you got to do is plug them in, right? Well, So I went looking for the wires. Where do the wires go? Where's the charge controller supposed to be installed? So I pulled out the circuit breaker box. And it's a combination circuit breaker and fuse box, and I pulled it out. That's what's behind it. Gotta love the Jayco or any RV manufacturer.
Mine's a Forest River and it looks just like it.
Yeah.
They're all the same.
They're all the same. So I didn't know where to look. I made some assumptions. I went through here. I didn't find anything. So I went on the roof and I plugged in a piece of wire and I hooked up a sender for an inductive cable tracer. And then right underneath, I knew where it was on the roof, so I went up there with the tracer. Yep, there's the wire. And I said, okay, it's got to come down. Oh, it didn't come down in the bundle that I thought it would come down in. Instead, it was laying on the ceiling, and it went all the way along and then came down into a wall. And that's the wall. And it's an inside wall that's part of it's in the hallway and the back of it's in the bathroom. And supposedly there was supposed to be a sticker on the wall. And if you catch the light just right, you can see the sticky spot where there used to be a label that says, install the charger here. But I found it. There it is with Mark's help, for sure. We found it. This is a funny wall because it's got this piece of wall and it's a curved wall. So I found it inside the wall and we spliced it so that now I had number 8s going from the roof all the way to the front bay. Except when I tested them end to end, one of them was open. And why isn't there a thing? This wire is supposed to be connected to that wire. And when I pulled it all out, the other one came apart. It turns out that when Jayco installed it, they used wire nuts and never twisted them. There were no evidence of twisting of the wires. They just pushed them on and put the gland on the roof and shipped it. So we opened it up, did splices on it, soldered them up real good, and then had to put it in. The white stuff is Dicor, for those of you that do rubber roofs. Sealed it all back up again. And we now had continuity from the MC4 connectors all the way to flying leads in the basement. So I was ready to do the next step. I started by planning. What I did was I got one of those 2-foot by 4-foot project boards you get at Home Depot and kind of laid out how I wanted things to mount. Using an MPPT charger. This is the circuit breaker I'm using. It's rated 400 volts DC. It's the DC spec that's really important because that's where, if you're not rated high enough, that's where you get the arc. I use bus bars. There's a solar place in Houston. Pair of the 600 amp bus bars was only $75. It's a bargain. They're even better than the Blue Seas. And I don't have the link in the slides, but if you want to know, ask me. The big switches, these are I think they're Blue Sea. This one's rated 650 amps. So you got to get the ones that are rated for the kind of current you're going to draw, the kind of battery system you're going to have. Fuse, 500 amp fuse, 650 amp. And oh, by the way, it needs 4.0 cable. That right there, that's $3 for 4.0 welding cable. Inverter, 3,000 watt inverter. That's a 400 amp switch with its own fuse. And I had the shunt in the trailer, so this is a 400 amp shunt with an interface box that converts that into Bluetooth so I can see it on my phone, what the state of charge of the battery system is. And then I assembled it. I decided to put the high power converters on that short mini strut or unistrut, and got it all wired up. Pre-wired it in the garage so that I could not be crawling, having my head poked in a cabinet while I was wiring it all up. So for solar, I use it's the 200 watt version of that same panel. It is rated 23 volts open circuit, 11.05 amps short circuit current. And I wired them series,
Going the wrong way.
the slide set did something funny. Okay, I got it back. I wired the panels, 3 panels in a series string, 2 strings in parallel. And that gave me 69 volts. And I'm using the MPPT charger. The MPPT charger is rated at 150 volts. So I'm well within the rating of the MPPT charger. 22 amps. Remembering this is at 25 volts, that can go up a good 10% when it's really cold. I provide a link later on that you can actually, there's a guy that's kind of funny that does RV electrical, and he does these little short videos, and he did one about how to calculate the temperature, the amount that these panels will generate at minus 40 degrees C. And a big long formula, and he cranks all through it, and basically it's about 10%. So, so you got to keep that in mind, that can go up. So because I had 2 strings, I used the PV connector combiners that you just plug them together. It's really simple. Oh, for mounting them on, for mounting them on the roof, the Renogy makes mounting clips for these. You mount in these holes, and you can put them on either the side or the end. For the panels along the edge of the roof over here, I put them on the end because the side of the roof has got a curve to it, and it's probably got an aluminum structure in there, and I didn't want to be drilling into that, so I used the end. There's plenty of walking room around around the air conditioner, and I got 4 in a row here and 2 more on that side. So that's it installed. Notice the circuit breaker's turned off at this instant in time. The shunt is showing me that the batteries are at 14.45 volts and are drawing, the facility, the house is drawing 1/10 of an amp. Probably most of that the CO detector. The bus bars with the Panduit on them really clean up the installation. Here's that DC to DC converter that isolates the tow vehicle. The 12 volts coming in from the tow vehicle from the 14.4 that's running there. You were asking about the order of things. It's very important that both for the MPPT charger and for the inverter that you apply battery power to them before the rest of it. So circuit breaker off, I can turn off the battery, and this will be completely off. And then when you fire up the system, battery first, and then the panels. The inverter, shore power comes into the trailer kind of on the other side of this wall. So I've got these two pass-throughs here that the this number 6 4-conductor rubber cable will go from the inverter and hook up to the shore power input, and then also feed the house circuit breaker panel. So it'll feed all the rest of the outlets. The dirty batteries here in the front, those are 200 amp hour LI time batteries.
Also used to be called ampere time.
Yeah. They work perfect. Had no trouble with them.
Amazon.
I used one, yeah, and you order them through Amazon and with factory support, and they were really easy.
How many of those do you have?
I have two, and there's room for a third.
Two 200s.
Two 200s, so I've got 400 amp hours. It's something over 5 kilowatt hours.
I'll run your CO alarm a long time.
It will.
Dave, explain the shunt.
Yeah, so what we want to be able to do is measure the amount of current flowing into the batteries or out of the batteries. So when, like, I'm going to go visit the trailer tomorrow down in storage. First thing I'm going to do is turn the power on. And when I turn this power on, this does turn off all the power, not like that silly disconnect switch. It will show me the current voltage, and then it'll start showing me a small discharge, which is the CO2 detector, likely, or a light if I left a light on somewhere. And then if I flip on the solar panels, it may switch to the plus direction, but it depends on the current state of charge of the batteries. I set the state of charge of the monitor to 100% when it's fully charged. And the BMSs in these batteries are pretty smart. They won't take more than they need. So, like, I turned on every load in my trailer that was on 12 volts when I first installed the solar panels. And I got this to actually say 13 amps that it was being generated by the solar panels. And this said 0 because batteries didn't need it. But because the MPPT charger was directly feeding all the loads in the trailer at the time. If I had been running off battery for like all night, then in the morning when the sun came up, then this would start to show current charge, and this would flip direction and show that the state of charge was starting to go in the other direction. So that's what it's for. And you know, I had the first battery and the shunt, the state of charge monitor, whatever you want to call it. I had that for a year before I put the rest of this stuff in. And very useful because, you know, you can run off 200 amp hours for a whole bunch of time.
So some of these MPPT controllers actually have a load out as well, right? But you're just running it as load on battery?
Yeah.
Is that the best way?
Everything's connected to my bus bar. Yeah.
The load out on those MPPT controllers are mostly used for lighting loads. And if you're doing anything else, don't use the output.
Like 10 amps or something like that.
It's not
very
much.
Question about the load out. What's different about that compared to the battery bus bar? Like, why would you put anything onto that load out?
The solar controller has switching ability on it, and it can turn it on and off itself dependent on load.
Okay, so just a load shed.
Yeah.
Okay.
Yes.
Did you put pass-throughs in yourself, or was that part of the original build?
There's a microphone for you. Would you repeat the question?
Yep. Did you put the pass-throughs yourself, or was that part of the original build?
So there were, the two black pass-throughs were already there. There were wires in each of them. The ones that were in this one, I moved down here. And then this is, if you go to Amazon, there's these pass-through, they're 3D printed. They're pass-throughs that screw together for like a wall, a studded wall. You sandwich the wall in between the two halves. So I bought one of those and used half of it.
Okay.
So
Thank you.
protects the sharp edges from the edges of the wire, so I don't damage the wires. So there's a lot of material here for anybody curious about any of this. The solar panels were the Renogy's, like that one.
You can grab this. You can grab this on the website, and it'll save you the eye chart.
Yeah, don't be typing this or writing it. The Go Power inverter charger, the Blue Sea products. Really like their stuff. They're mostly Blue Sea, right? It's marine rated stuff, so works great. And the PV, specifically the PV circuit breakers, are an important point and different from those. The pveducation.org website, that's where I got the models earlier in the presentation for tilt. And the amount of insulation that you get, and there's a lot of good stuff under there. And then this guy, Explorist Life, not only is he funny, but he's got a lot of good practical information. Stuff like how to strip a wire, which some people really need, probably none of you. How to crimp. So he's really good at breaking it up into and doing a whole playlist of topics. But then he gets into the solar panel series and parallel, temperature compensation, batteries, the whole thing. So highly recommend that. And another one about that's his video. This one is his video about the low temperatures coming out of solar panels. Okay.
All right, so what you're seeing here.
But before we hit this, does anybody have any questions on this? This is a lot of good info that Dave just went through. There's got to be some questions.
What you're seeing.
And if you're online, you can come off mute. And,
Yeah, feel free to stop us. You can talk and
yeah.
we'll hear you. What you're seeing here is a project that we started 2 years ago, or was it 2.5 years ago? It was February, I think, two years ago. This trailer was given to us by Channel 4. It was a trailer that they used for the Aurora Theater shooting. They were using it as a video production facility. They were actually doing remotes out of this trailer. And it had sat in their yard downtown since 2005. And they're like, come and get this out of here. So we were trying to figure out what to do with it. Well, this is what it ended up as. So there's 2,700, that's incorrect there. I think they're actually 275 watt panels. It's actually about 2,500 watts of solar with two 1,250 watt arrays. There's 5 panels on the side and 5 panels on the top.
So John, we've done a whole lot of numbers. Tell us what you use this for.
You see this? See this right here? This is a full-size refrigerator.
Yeah.
When we go to field day, we always have a problem carrying cables, sleeping people, and keeping things that we can eat. So that is why this got built. There was no other reason other than to get a refrigerator there. The interesting part about this, you can leave that refrigerator.
Always going hungry at field day.
I don't think that field day and hungry in our book does not go together. It is, yeah, this is the GOTA station that you see here. All of the cables, power, whatever we have that needs to get transported, grills. There's a griddle that goes in here. and there's 2 places to sleep in the front. So we took and created something that was useful, that was basically universal. We could use it anywhere.
That generates its
That
own
generates
power.
its own power.
And you can see from the talk today, now we don't have a photo of under the front
No,
bunk,
we don't.
but-
It's got 48 volt battery plant, 200 amp hours at 48 volts.
Of what
It's
kind of chemistry?
lithium iron
Lithium iron
phosphate
phosphate. So-
with heaters that I built into it. I didn't use heated batteries. I actually put heaters under them, and I separately control the temperature of those. But the interesting part about the whole thing, this uses 3% of the power overnight. Running that refrigerator is 3% of the power. This was designed that we could go somewhere and be self-sufficient without having to run motor generators. We ran the GOTA station in this for all of field day last year and never plugged it in. It's perfect for what we do.
So what I wanted you to take away from this is we've talked about to tilt or not to tilt. You can see here we have a hybrid. We have a fixed panel on the roof. Normally that side panel there is flipped down and it's vertical. Or it can be tilted, as Dave taught us. Yeah, you can get a little better, but you can get a lot. There's a small mini split air conditioner you can see there that runs off the solar in the inverter. There's at least, 600 amp hours of battery?
It's 800 amp hours at 12 volts, but they're
A
in
lot.
48 volt strings.
A
So
lot.
there's
So-
200 amp hours at 48 volts.
Underneath one of these bunks where it's a little bit temperature controlled because John has the heaters, he has some styrofoam around it, he's got the bunk on top of it so it can stay warm. We've got a lot of DC power that we can then run into an inverter and power the trailer. He used a charge controller that has a remote display that he's placed clearly on the wall right behind the other side of the wall from that refrigerator so we can see and manage what's going on. This trailer right now is deployed temporarily. It's actually up at my house, and we're using it to power the microwave radios for a change in our backbone where I had space for a tower, but I didn't have electricity out there. I have a 7-acre property now, and we needed to do a microwave link for the RMHAM backbone. So we brought in our tower trailer, which doesn't have any power, but it holds a microwave dish very nicely. I said to John, well, how are we going to do this? Are we going to run a big extension cord out from my house? And he goes, well, we got the bunkhouse. So the bunkhouse is sitting with a panel vertical or horizontal on the roof. The side panel, we didn't even deploy it out. It's perfectly vertical, and we're charging, and we typically draw about less than 5% of the capacity overnight without a charge. And Tristan, if you could, and we've now added the Longmont Amateur Radio Club. We're running a test transmitter repeater there at about 50 watts, plugged into the inverter, and the thing doesn't even see it. So you had a question.
Yeah, in the theme of, vertical, angled, horizontal, do you fuss much about south facing too, or not?
Yeah,
yes.
it needs
Oh,
to
you do?
face
Okay,
south.
so
Yeah.
you-
Yeah.
Because that's not always,
It's-
you can't always get that. So
You
I'm just
can't
curious.
always get it, but as close to south as you can get is good.
So I think this is actually my property. Does this little thing work? No. Yeah.
You can't see it.
It's not. But where this thing is I can't get to it, but
It's
right on the south end of
right
my
over here.
property. There's not a tree in the way, and it just looks south. And 90 some miles away, you can see Pikes Peak sticking over the horizon. So we get a lot of sunlight there. But this is a lot of what we looked at today. Would you guys build one of these? Maybe. Not everybody in here will, but some of you take all of these parts. I think we used not Victron in this one.
This has an EP Ever all-in-one,
ever.
which is charge controller and inverter, and I strongly suggest you not ever buy one of those.
So, yeah.
They're terrible.
You notice he's got a shore power in, so we can boost from, if we were at field day and it was totally cloudy, or we could plug something in to charge. We've got outputs. It's a nice implementation. Then this is just what we talked about, 2 of our solar sites. And the big photo is our Mosquito Pass or Mosquito Mountain. That's like 13,000.
13.5.
500. And you can see the panels up there. Some of them are older, some of them are newer.
The site was built in the mid-'80s. It's very, very old technology, but they still work. They're just not as efficient.
We talked about, yeah, this is just the little pointer doesn't work. But we talked about mono versus poly. I believe by looking at these, we have a hybrid.
Yes, there's both there.
So you can mix and match and get what's affordable. We've talked about to tilt or not to tilt. This is the Breckenridge Baldy
Right
site here.
The lower picture is
I'm trying to
Breckenridge
do
Baldy.
this for the guys online, and this little thing used to work better for pointing.
You gotta load the driver.
Oh, okay, is that what it is?
I was talking earlier about the metallic look of a poly panel. This is really demonstrating that metallic shiny blue surface. That's a much older panel.
Old style polycrystalline, very, very old. Those are probably 90s vintage.
Yeah, and these circular ones right here, I don't even know what that is.
Those are ancient.
Yeah.
Yeah, and
Are they?
are they?
Somebody in the audience said they are Siemens panels. Do you know about how old they are?
Yeah, they date from 1980.
1980.
1980. So we
Thank
don't
you for
have
sharing
quite
that.
use carbon dating on them, but they're old. And so this is the Breckenridge, Colorado connection, and RMHAM squats at this site. This is the building that in about, 2003, 2004, blew over in a windstorm and pushed about, I think it was like 50 feet down the mountain. Baldy is like 13,002 or something. And you notice that you see some guy wires here. Now, let me step by you, John. You can see in the photo some guy wires. And that's not on the tower, that's on the building, to keep the building from in place. But these solar panels have survived. But when you're up there, if the building is going to blow over, what are these panels going to do? How much do you have to anchor these things?
A lot.
So they anchored one to the building, and there were some mounts up here that we could do. Inside, there's very old AGM and gel batteries that frankly need to be replaced. This site was totally off-grid and offline before. They now have a power line that literally is like triplex running up the mountain. It's thousands of feet. And they boost the base voltage to almost 200 volts so that we get 120 at the top.
They tap the transformer to get the right voltage out at the top.
And we get a little bit of power. We've been told in the past we're allowed to have, I think, less than 50 watts. So imagine one old incandescent light bulb that we're allowed to take off the AC line. And so we typically use that as a supplemental charger on the battery system, and all the equipment runs off batteries. So everything that we did in the process, and I was going to talk about this, but then when I looked at the slides, I said, you know, when you're co-presenting with people with this kind of knowledge, sometimes it's best just to say, I'm working on a project, and I don't have to be the smartest guy in the room, because we do have the smart guys in the room, but this is my new property that I'm doing, and I've got lots of area. Can you reach that thing, John? Please.
Do you want me to give it to you, or do you want me to hold on to it so you don't drop it
I think
again?
we're about going to go to questions, because, Willem, we're supposed to be about 11:30, right?
Yeah.
So we're sliding into this perfectly. So I bought this new property. I'm no longer in the town of Firestone with land use code. I'm no longer in an HOA. I've got 7 acres with a very long driveway and lots of space, and it's on a nice little ridge. Some might call it the grassy knoll. I call it the weedy knoll. And a little tiny farmhouse, but I'm gonna build a ground mount solar array, probably out in here. I might put it further in the back and feed it to the barns and things so that we can do repeaters. I can basically power myself. And so when I talked to Willem, 6 months ago, I said, we should do a university class on solar because I have a lot of interest. I need to learn. Well, I know a number of you have probably moved recently in the real estate market. It doesn't go as fast as you think it's going to go. So I'm behind on this project, which has allowed me to learn, and I'm going to use all of these, and that's why we were going through some of this material to say, these are the building blocks, and you can build any size you want. So I think that's the last one. Before closing announcements, what do you guys think, want, questions? We'll pass the mic around to Perry here.
So I have a question about inverters. And my understanding is that one of the weaknesses of inverters, if they are on, they're drawing current, even if you're not powering other devices or they're not supplying current to other devices, the inverter itself has a lot of loss. Is that correct?
They have some. It can be in the 100 mils. I mean, you look at the spec, right, and it'll tell you what the idle current is. That was the idle current thing I talked about earlier. The MPPT chargers are the same way. They have an idle current. Even if the sun's not out, they're still drawing a little. And inverters are the same way. Yeah, for sure. By the way, I wanted to point out a particular tool. A lot of people have probably seen one of these. But they're AC only, right? Well, this is AC and DC. And when you're working on battery systems that have this kind of wire, this is a 400 amp, or I think it's 400, a 400 amp DC current meter. It clamps on. It's really convenient for working on solar power systems.
Bob Whitty talked about that in one of his test equipment. And what brand is that one?
This is a Klein.
That's a Klein, and those are pretty good. Bob's comment was the DC is not quite as accurate as the AC. Is that what you're finding with the current technology?
Yeah, I was comparing it against my state of charge shunt.
Okay.
And it's close. It's close enough.
You're talking like a few percent or 20%?
No, more like a few percent.
Okay.
It sort of has to do with, it's inductive, right? So you got to kind of center the wire in the hole sometimes in order to get a good reading.
And once again, you can get it from the Smiley people, or you can probably get those at Home Depot even.
So they may have these at Home Depot or some other place for Klein. A brand that's becoming popular, and at Hamvention last year they had their own booth, and it's Unity, UNI-T, and there's a model. They have a model like this that's both AC and DC. It's quite reasonably priced. So I wanted to point that out.
Got any other nifty tools there to show and tell?
So this is the MC4 crimping. It's got a tool for unconnecting the two because they snap together pretty good. And I think Tristan used his fingers to snap it apart, but there's a tool for that. And there's a wrench for making sure you get them nice and tight because they crimp on the back. It's part of their waterproofing. So, and then the crimping tool for the, it came with a half a dozen of the MC4 connectors. Again, Amazon is your friend. And this is, I found that Bouge RV as a brand, There's a lot of their solar stuff on the website that is, I bought some of their cables and connectors and the crimping tool. And it's all worked out pretty well.
Any other questions?
So like you were talking about when you were building on top of your RV and space is a premium, some of the things that are happening on the overland community is they're stacking their solar panels on top of each other and using the heavy drawer slides to pull them out. So you can now get double the amount of solar when you're stationary, but you still have half of it when you're traveling, and you just pull it out. You get a little overhang underneath that you can stand under, but you still get, now double the solar that you originally could have had.
That's clever. Yeah, that's clever. Reminds me that last year at Field Day, James Isaac he had some extra panels in his garage. So he brought them, and he made, just using PVC, he made some stands for them. He daisy chained them and ran them into his trailer, and he'd installed another MPPT charger. So he actually had like another, 1,000 watts of, he had another kilowatt standing out in front of his trailer, kind of tilted it at somewhat optimum angle in order to keep he had to run the air conditioner all the time because of the dog or something.
Yeah, but he never plugged in for the whole week we were there.
Exactly. He was totally off grid the whole time we were there. And we run a big generator sort of when everybody shows up. But early in the week, it's just off bunkhouse or our own stuff. So works pretty good, especially with all the sun we get around here. Yeah.
I thought I was under the impression, stuff you read, that you shouldn't mix and match the panels, but you guys, one of these, elevated installations had poly and mono mixed. Are you saying, like, no matter, as long as you don't overload on your voltage or amperage, you're fine and your components can handle what you're doing?
That's multiple charge controllers. So
If you've got different, you can probably see my head here. If you've got different types of panels, you shouldn't mix and match them. You can mix different voltages as long as you don't exceed your maximum voltage. It's fine. It won't hurt anything. It doesn't matter. You could I've got 3 different manufacturers of panels on mine, but they're all still the same. They're all monocrystalline. It's not really a problem. As long as you don't exceed the maximum voltage of the string that's written on the back of the sticker on the back of the panel. Show them where that one is, Dave. It's the maximum. Yeah, don't exceed 600 volts DC, but you can series up as many of those as you want. I've got 12 volt 200 amp panels or 200 watt panels, and I've got 24 volt 135 watt panels seriesed up, and it's fine. As long as you don't exceed what your charge controller can take, you're fine.
Yeah, those are all the same. So those are all Renogy. And another thing I was going to say about panel selection when you're fitting on a roof, the standard panels that you put on the bunkhouse, they're about 39 inches wide.
Standard is 39 inches wide for the most part.
I don't have 39 inches, so I bought the 28-inch ones because they'd fit. So you got to consider the size of the panel as well as.
There's many form factors. Just pick the one that fits what you want.
Yep.
My panels are 15 inches wide and 15 feet long. They're flexible and they glue down.
So question for Dave, in your photo here, right up at the corner, is that just an artifact on the photo, or is that?
Nope, that's goose poop.
So do you have a throttle back for goose poop? Is that a?
It's shadow.
That's a shadow.
I need a robo panel cleaner that'll.
So what happens when one of those panels fail?
When it fails?
So I have some of those flexible panels, and they're not flexible in the sense that you can fold them up, but they have a little bit of flex in them so that they actually fit the shape of the roof, and one of them delaminated. What happens when there's some kind of a failure like that? Either
Willem goes and buys more panels. That's what happens.
Is it open?
No, it actually basically, gave you half the voltage because the way that it's a 18.5 volt panel.
Okay.
But, just the lower, or the one of them just failed, and so you got 9 volts out of the panel.
Well, the voltage on that string will drop. Is it one string or 2 strings?
Single string, but the interesting thing was it didn't go open circuit. It basically you didn't get any generation out of that. And I guess it just all depends on exactly how the failure happens to occur.
Yeah, and inside the panel, it's series and parallel too, right? So if you lose some of those die or elements or whatever the construct is, those just drop offline, and it might take a string. But if you have multiple strings in parallel right in the panel, I'm pointing at the back of it that nobody can see.
If you have all of your panels series,
You lose the whole.
Yeah.
if you have a parallel that you need for the wires, John pointed out, so if you have a series parallel, it may just drop a little bit, and you might not even.
Yeah.
So that's the importance of the metering and other pieces they show.
Yeah, you live in a house and you don't pay any attention to the resources. They all just work. Faucets work, lights work. But in a trailer, you got to know all of them and you got to pay attention. So I don't know how these are wired, but if you would assume this is a string and this is a string and this is a string and you lost maybe this one, you might lose a third if that's how it's wired.
Yeah, I mean, each of those basically produces 0.7 volts, right? There's basically a bunch of PN junctions, and they just string a whole bunch of them together internally. Each one gives you, 3/4 of a volt, and you have enough of them in series, you get the 18.5, which is sort of the standard voltage.
I'll give a little bit of a shameless plug for an upcoming talk we're doing on antennas, but there are some antennas that you can build, especially for VHF, UHF, like collinear antennas, that are multiple sections all seriesed, and depending on when that series connection between the elements breaks, you either get a very bad match or a 50 ohm match, but half the antenna is not functioning. And how do you know that, gee, I instead of 10 dB a gain, I only have half of it running, I have 3 dB down? You have to have some tools and sweep it. The same thing with here. You've got to really see into what's going on because, Dave said it quickly. When you're in a trailer, you're on a solar, you got to pay attention because it's not the fault. The water comes on, the light comes on, the drain works. Well, in my case, it didn't, but I fixed that. That property also has a farmhouse built in 1900, so lots of opportunity to fix things. So these are like an antenna. And Willem and I are doing an antenna talk, so the shameless plug, and I asked him to put this in, but since this came up, I thought I'd do it. In March? And we're actually going to do it antenna tapas, small plates of antennas that you could actually build, as opposed to showing you a photo of the 80-meter 3-element Yagi that a friend of mine put on his 200-foot tower. You're never going to build that. We're going to do things that you can do and some of the theory behind it. So if you have a favorite antenna that you're building, you're using, you use for POTA, we will schedule some 10, 20-minute tapas, small plates that you can present that. Just let Willem or I know if you're interested in sharing your killer POTA antenna or SOTA and Summits on the Air. Other people may want to build those. So, no other questions? Oh, let me send the mic back to you.
I'm sure everybody knows Just like any other subject on YouTube, there's good information and there's bad information, so pay attention to what you're watching. But one particularly good channel is this young engineer named Will Prouse, and it's DIY Solar with Will Prouse, and he's got hundreds of videos, especially on ground arrays and batteries and everything. He's just got some really good information on there.
I'll second that. I've watched some of his stuff.
He has a book, and I keep it because I can't always get a connection, so I keep his book on my rig.
So there's you got a solar or a battery charger up there that's the RC1. So those have always been interesting because you can hook them up to any old battery that you've got. And if you get in the field day, whatever, you can hook them up to just about anything that shows up. So those are typically powered out of 12-volt DC power supply out of the wall. So has anybody successfully just taken and hooked up a solar panel to the front end, to the power side of that? And what's the result? Yes.
No.
Yes. Okay. That's been my experience too.
I think even if the maximum voltage of that panel is below what that charger can take, and it has a pretty wide input voltage range, like we talked about earlier, these things are not voltage sources, these panels. You will bog it down if you are not careful about what current you're drawing depending on the conditions. That's why we have those MPPT or PWM controllers that we mentioned earlier. They help you adapt your load to the panel and squeeze as much power out from those panels as possible, depending on the conditions. So I think it would probably come up, and then maybe a cloud comes over, then the controller would reset, or it would brown out at some point. It would just be really chaotic charging behavior, I would guess, if you're not using a charger that's designed for use with a solar panel.
I mean, it's a really good point about the voltage of the panels, because you go and you'll look at a website, and these are 12-volt panels, these are 24-volt panels, and no, they're not. They're a reasonable size to use with an MPPT charger on a 12-volt system, but they're not 12-volt panels. Some people think, oh, I'll just plug all these 12-volt panels in and hook into my battery. No. It doesn't work like that. You got to have all the pieces in the system. Yeah. Anybody else?
So Dave Blaylock, N0 PEO, has a really cool thing here, and I said, "What's that?" And I said, "Why don't you give us a show and tell?"
What this is a device to check the solar insolation, what your area looks like for solar, to see where the trees are for all parts of the year. And so what you do is you set this down where you want to see how the solar, where you want to see how it looks, and then you can draw all of the shadows and things that trees or whatever happens to be, or buildings are, so that you get really a picture for the whole year of what that site will show for the, for what you're. Yeah. And they have camera-based ones now. This was from probably about 1990 or before, so it's been around for a little while.
We'll pass it around a little delicate, but check it out.
Probably will.
So any last questions before we wrap it up? If not, thank you all very much for attending. I guess take-home lessons from today is you get what you pays for.
Make it so.
Not
it's
all
already
equipment is
selected.
of equal value, and
don't
watch
even have
out.
to
There
click it.
are some very high energy densities and
It'll-
very
it'll
high
automatically
voltages
do it.
involved with these
Yeah.
things. So please be careful. You can kill yourself with this stuff. With that, thank you very much. I want to wish you all a very Merry Christmas, Hanukkah, Festivus, whatever midwinter festival you celebrate. I celebrate all of them with great gusto. And please keep in mind what we asked for NerdFest. Please go to the RMHAM website and sign up. And as Doug mentioned, if you have some contribution that you want to make to our antenna talk in March, please contact either Doug or I. We would be very happy to hear from you. So with that, thank you very much.